Okay, guys, welcome to the CS425. First of all, let me introduce myself. My name is Yusuf, and this is my 4th year at the IIT. And don't worry, this is not the first time I teach this class. This is my email. If you wanted to communicate with me, if you wanted to send an email, if you have any questions, feel free to reach me at any time. Definitely, I will try to reply to you as soon as possible. My research relates to the data privacy and security, so I'm related to the database in general and the security. This is my office hour. First of all, this is my office location. I missed that place. I'm not sure we do have the Stewart building at the IIT or not. I didn't see my office since last year, actually 1 year and maybe 4 months now or 3 months. Hopefully we can get back to normal during the fall semester. Following are my office hours, each Fridays from 12 to 1. I'm definitely going to perform this one virtually using the Blackboard. Okay? If this time doesn't work with you, feel free to send me an email, okay, so we can figure out an alternative time, or maybe I will try to answer your query or question. So mainly we're going to use in this class 2 different platforms. The first one, the Blackboard. So we're going to use the Blackboard mainly to conduct, in order to post the lecture notes. As you note, that the lecture is going to be available in advance as a PDF file. The assignments, the homeworks, and the syllabus are going to be in the Blackboard. The Piazza platform is going to use for the class discussions. I encourage you, if you have any question, to post your question publicly in the Piazza, so you get a chance to, if you want to try to participate, if you want to try to answer this question, if you know the answer for the other student question, I encourage you in order to post your questions or the answer there. I will try to answer the question in a timely manner, okay? We didn't have a TA this semester because we didn't have enough students. I guess the number of students right now is 10 students. The university is not assigned TA unless we have, let's say, 20 students in the class. So this is okay. We don't have too many students, so I can manage in order to go over every single student request. If you have a question, any concern, please reach me out. As you notice that the class is going to be completely virtual. It's going to be a virtual class online. I will live streaming the lecture like now, okay? And after this, I encourage you to attend the live streaming class if you have time. If you can't, there's no problem. I will record the classes and I will post the recording after the end of the class. Maybe I need more time in order to post the recording. Generally speaking, I'm teaching 3 classes during the summer. So I do have a class in the morning. I do have a class after this, right after this class. So don't worry if you feel like you found out the recording is not available right after the class. So it depends, maybe. Hopefully, I will try by 6 o'clock and they'll be available, the recording, if there. You can access the recorded lectures whenever you need them. It's available there. We do have a short tutorial. Hopefully you get a chance in order to take a look at the short tutorial, because it's available in the course Blackboard, which help you in order to show you the way how can you attend the class, okay, during the live streaming, which most of you are there. Allow you to show you how to locate the recorded lectures. It's going to be available in the content. Within the content of the Blackboard, you're going to find the lecture recording. So you're going to find every single recording right after the class. And also the way that how can you conduct the office hours. The same way that you log in live streaming, there is another option that's going to be available online during my office hour. Okay. In the Piazza, I encourage you in order to sign up in the Piazza, the link that's available in the course syllabus. Hopefully you get a chance in order to sign up. It's a good idea. I encourage you, as I mentioned, in order to post all your questions available. It's going to be publicly using the Piazza, so you get a chance to all the students to participate. And means if you answer the question, maybe someone else have the same question, so it's going to get the benefit of the question. Lecture is going to be like the slides, PDF format. It's going to be available post before the lecture. You notice that the lecture of today's class is available. Hopefully either today or tomorrow I'm going to post the lecture of the next lecture. Before the end of this weekend, I'm going to post the lectures for the next week. So in advance, you know that what's the content that we are going to cover. The lecture slides are going to cover the essential materials. I will try to cover the same thing using different ways, okay? We're gonna go through the lectures. We do have some homework assignments. I'm gonna talk about the workload, more details. We do have a class project. We're gonna see later, we're gonna talk about this one, more details. Exams, we're gonna talk about the exam workload. Yeah, by the way, if you notice that I'm speaking fast, or maybe it's not clear to you, please feel free to stop me at any time. You can say, hey guy, stop, wait a second, I can't hear you, or maybe your language speaking is fast or not clear to me, so please speak slower. I'm trying to speak slower. Don't worry, okay? Right now, I'm speaking slowly, but within the class, you're gonna see that I'm starting getting excited, then I'm gonna speak fast. Okay? So what they expect from you? Definitely don't watch Netflix while or during the live session. Okay? I expect from you to attend the live streaming lecture if you can. If you can't, there's no problem, okay? So the attendance is not mandatory. I expect from you to be active and think critically. So we're gonna see during the course of the semester of this class, sometimes they're gonna ask a question. So I want to expect from you to participate, to try to answer the question, especially later we talk about the SQL queries, etc. So I'll maybe give you like SQL command or statement and say, what's the problem with this one? What do you think is correct or not? How can you make it better, and etc. Do all the assignment and please start early. This is short semester. It's around 5-6 weeks. So you see that almost every week you're gonna have one, let's say, homework, okay? And you are going to get involved in your class project. So it's easy course, by the way. It's a nice course. I like this course, okay? It's not required from you to memorize anything. Just understand, do the assignment, and start early. And please be honest, okay? And of course, expect from you to study for the exams. So no Netflix. Okay, this is no. Good. So I expect from you to take a lot. You already took a lot to the course syllabus. If not, there's a chance to take a lot to see what's going on in this class. Which go to practice for every single course that you're going to attend. This is your chance in order to take a look to the course syllabus to see whether the objective of this course makes sense to you. Whether this course is going to help you in order to add something to your CV or your knowledge about the computer science. I know this course is like required, so you don't have a chance, you have to take it. But for the elective courses, maybe you're going to take a look at the objective of this course to see whether this course makes sense to you to take or not. Anyway, the course syllabus is available in the Blackboard. If you don't have a chance to read it yet, please read it. Because it's going to contain all the information that we cover. One of the important slides in today's lecture. The workload and the grading year. So exams is going to be the midterm exams is worth 20% for the overall points, okay? It's open book exam. And the exam is going to be 3 hours, okay? And this is the expected day of the exam. I know that many students are working at this time from 1 to 4. Maybe it's not going to work with them. So maybe I'm going to, the exam start time is going to be from 6 to, let's say, to 9. Exam since it's 3 hours p.m. I will see. Well, let's start with the semester. During the course of the semester, make sure that all the students are going to be, no one's going to drop the course. And then next week we can revisit the slide and see what the best time for us in order to conduct the exam. I believe maybe instead we have the exam from 1 to 4, or they say 1 to 5, since it's 3 hours. I give you an extra hour, by the way. Most of the students finish the exam within the first hour. So I give you more time in order to make sure that you have enough time to answer the questions. Okay? So it doesn't mean 3 hours. That means you are going to spend the whole 3 hours or the entire 3 hours to finish the exam. No, you don't need them. And you can start at any time. But I encourage you to start at the beginning of the exam in order to get you more time. Anyway, maybe the midterm exam is going to be from 6 to 9. Okay? Not in the same time, because make sure that everyone can attend the midterm exam. This is the expected date for the midterm exam. Okay? The final exam is going to be the same thing. It's open book exam. It's going to be 3 hours. And this is the final exam date, which is going to be the last day of the class. We do have a control about the midterm exam date, but we don't have control of the final exam, because the final exam expect that's going to be the last day of the class. Okay? And again, it's gonna be from 6 to 9. Unless you have another class or it's gonna this course or this time it doesn't work with you, so please reach me out. Okay? So again, it's open book exam. You can use whatever you want to use. The only thing that I don't want from you like you to use is try to Google the questions or try to participate or to get help from one of the classmates. I trust you, so please do your own work. And the exam is easy. Again, you're gonna see that we are going to cover everything in the class. So you're gonna know exactly what the exam format looks like before the exam time. Okay? We do have homework assignments, which worth 20%, sorry, which is gonna be good preparation for the exams. So actually, we do have homework assignments. Someone is gonna say, "Wow!" Yes, why? Because, for example, when we talk about the ER model, I'm gonna give you homework just to try to practice that. We talk about the SQL query. We divide this one into say advanced and say intermediate level for the SQL language, query language. So I give you two different, homeworks. One, to cover the advanced, say the introductory part or the intermediate part of the SQL query language, and the other one gonna help you in order to practice for the advanced commands. So all of them is easy to do. I believe the homework maybe is not gonna require from you to maybe spend 1 hour, 2 hours at most. Okay. So we do have 4 coding. Keeping saying coding assignments is a homework assignment. It's worth 20%. We do have a course project, which is worth 30%. So you expect from you to divide yourself in groups of 3 students at most. If you want to work alone, it's okay. If you want to work in groups too, it's okay. It's your choice. Work with maximum 3 students can work in a group. So what do you expect from the group here? Or what's the course project? We are going to cover everything in the class. So for example, assume that we have a ticketing system. So we need first to develop what is called the database model. I'm going to show you the class how to clearly do that. Then after that, I say, please, now phase 1. We have to finish the first part. Generally speaking, I will give you the description of the project. I might post the description of the project maybe tomorrow. So at least give you a chance to see what the content, what the expectation, what you try to implement in general. Okay, so we start step by step. With this information, you need to find out a way how can you develop the database model, how to create a database schema. In other words, how can you put the data in, say, tables? Yeah, with the second phase, which is going to be covered in more details in the class for every single phase. So the class project is going to be 3 phases. The first one is going to be develop the database model. I'm going to cover this one in more details in the class. I'm going to say, now we have a few days in order to finish this one. Then after that, we have phase 2, which is going to derive the database schema from the model, convert whatever the structure that we have into the corresponding data model. So you convert in the table. More details are going to be explained during the class. You're going to see that. What do you mean exactly? How could you do that? It's simple steps, okay? Then after that, the phase 3, which is going to be the last phase, it's going to be implement the application accessing the database. So you're going to build either going to be web developing, a web application actually, or desktop application. It depends on you. Whatever programming language you prefer to use. During the class, I'm going to show you that how could you use Java and Python in order to connect to the database. I will give you like a short tutorial. It will be available online with like 1 hour and 15 minutes, I guess, which allow you to show you how the steps in order to help you using the Java in order to build the web application. Okay, so it looks like the class project is contains of 3 phases. Phase 1, develop the database model. The phase 2 is going to be derive the database schema from that model that you came up with. And the third step is going to implement the application accessing the database. There is another chance. If you don't like the class project, I'm going to assign to the whole class. You have until next week in order to come up with an idea. You have to tell me that you do have another idea to build the class project. So you have to tell me what you're planning to do. And you have to get my approval, whether you're going to continue or apply, you can use your own class project, or you have to do my class project. Because I want to make sure the class project has all the components, allow you to practice whatever we are going to cover in the class. Make sense to you guys? Good. This is, I mean, the great distribution. We do have an undergraduate and graduate student. The only difference between them, the graduate student doesn't have, don't have, D. They have A, B, C, and E. It's easy to get A in my class. The only thing that you need to do here, you do the class project, you do the homework, try to do your best during the midterm, the final exam. The question is easy. The exam is easy. The goal here on this class to make sure that you understand how to use, design your database. How could you create or use the SQL in order to retrieve the data and perform some modification to the data? Okay, so it's easy to get A. It doesn't hurt me if every single student get A. At the same time, it doesn't hurt me if every single student get F. But as I mentioned, it's easy class. Database CS4 to 5 is one interesting class that I love to teach. Because, for the student, doesn't require from them or don't require from them to memorize anything. Just understand, then apply. Then I'm going to show you, help you, how could you apply this one. So I'm going to give you like a chance in order to practice the SQL query and the statement that we cover in the class using one of the database management system. We're going to adopt the Postgres, the open source database management system, which is the simple one in order just to try to test whatever we cover in the class. I'm a big believer that from the student, learn it by doing. I can't memorize the stuff, so I cannot expect from the student to memorize too. Okay? So this is for the undergraduate student, the great distribution, and this is going to be for the graduate student. So what's the course objective? The end of the course. We are going to understand the underlying idea of the database system. So just to give you an idea, what do you mean by the database? What do you mean by the database management system? For example, you hear MySQL, Postgres SQL, you have Oracle, and etc. What do you mean by this one? To give you at least you're going to have the understanding the underlying idea of these database management system in general. By the way, I have cold, so don't worry. We have online, so you are safe, okay? Unless the virus is going to be propagated to you online, okay? That's why my voice is that's why I'm speaking slower this time. Anyway, you are going to understand what do you mean the relational data model. So you're starting this lecture, you're going to explain some terminology, the way that in order to allow you to organize your data in a specific model. You're going to be able to write and understand the SQL queries and the data definition of statements. And by the way, either use SQL or SQL is fine. Both is fine. Okay? And by the end of the semester, you're going to understand the relational algebra and the connection between the relational algebra and the SQL or the SQL query language. You're going to understand what's the most important thing, which is going to be the phase 3 in the class project, how to write a program that acts database server. So as you're speaking, the database is going to be stored here, might be in the server. And here you're the client, you're going to send somehow using Java code, either going to be Java or Python, in order to access the database and retrieve the result. Okay? Understand the AR model using database design. In other words, you start with someone going to hire you in the future. You're going to say, okay, we want from you to build this web application or say a desktop application that has a back-end database, which is going to require to access, retrieve, store the information in the database. Okay? So one way to perform that, when you start design the system from the scratch, you are going to collect information, with the information going to be available for you for the class project description. Then you're going to start designing or building your database system or database itself. So you start with what is called the entity relational model, with the way in order to help me in order to design the database. What does that mean with the design database? You collect all the attributes that you want to store. For example, let me give me a simple example. Assume that you have the student ID, the student name, the GPA, and etc. Many information that we have stored about the student, all about the university system. Then now we need to figure out a way how to organize this set of attributes in a relational table, on entity. You can say, I'm going to put the information about the student in one table, or one relation. The information about the instructor, it's going to be a separate table or separate relation or separate entity. add it to it. Then after that, you are going to define the relationship between the student and an advisor or an instructor, something like this. So that's what's called the AR model. Don't worry, you are going to cover each step in the class. Then one step or another step of the database design is called the normalization, which maybe you didn't need to perform this one, or maybe it's going to be almost 5% from after you design database. Maybe you need to acquire this step. It's easy. We're going to cover this one the last week. It's starting to define, for example, how can you tell the design that you have is good design? So you can't come up with the bad, figure out the easy way in order to answer this question. It's easy to identify or decide whether this design is bad. Then after that, you start fixing this design, which is a good idea, okay, to make sure that your design is going to be good design, okay? Then after that, take a look to the index structure, which is the way that in order to speed up access with the specific data structures, which allow us in order to speed access to the data, is called the index structure. We're going to see how can you build the index, how it looks like. If we have a time, it depends on the time that we have here. We're going to take a look at the basic understanding for the relational database concept. So take a look at the concurrency control. In the database management system, we expect that we have a not single user. We do have a multiple user going to access the database, right? At the same time, simultaneous. So we need to have the concurrency control. We need to figure out in a safe environment, safe way, allow multiple users to access the database. Recovery or query processing. Recovery, that means we need to have a recovery mechanism in the database management system. Yeah, for example, Postgres, SQL, etc. We expect that we cannot guarantee every single transaction query can be executed. Sometimes, assume that you transfer money from account A to B. For example, you take $100 from account A and you want to store this information in account B. Once you detect $100 account A, the system will crash. So there is a failure happening in the system. How could you recover to the most recent consistent state? Make sure your system is stable. That was called the recovery mechanism. Query processing we cover if we have a time, but I'm not sure we have time this class. It's going to take a look at the way that once different steps that once you send your SQL command or statement, how the database management system starts or figure out a way or the best way or best plan in order to execute your query. It's similar to the way that when you define or create your, code in any programming language, yeah. So you need to compile this code. How did compile the code is going to be compiled during the compilation, the process during the system. How the system is going to, or the compiler start with the source code, translate this one in parse tree, and etc. in order to execute or find the best way in order or change this one or convert or produce, let's say, the machine code. Okay. Here for the database management system, you start with the SQL query. The system try to figure out the best way in order to, or best plan in order to execute this query. Or in other words, the fastest one. Okay. And the access control here we have kind of mechanism that you want to enforce. So you're going to decide who can access what in the data. Okay. So again, this part, maybe we didn't have time to cover this one in this class, but we usually cover this one in CS5 to 5 in more details. Okay, so I will try, it depends on the time. If I had time, at least to give you an idea about this one. If we get a chance to go over this one, I'm going to cover this one in the class, but it's not going to be part of the exam. Okay? Okay. So as I mentioned, we are going to use, specific database management system. Feel free to use whatever you want. Just, I'm going to focus on use the Postgres SQL. It's open source. You can download in your machine. I'm going to give you I think tomorrow, maybe not tomorrow, next week, yeah, once you start looking at the Postgres and such a SQL query. So I'm going to give you a short tutorial, which show you step by step, how could you download and install the Postgres in your machine. So you can use the database management system, then you can practice whatever we cover in the class using the Postgres, which the best way in order to understand the SQL query is doing what? Is doing, by practice, by doing. Okay. Back to the course project. First, you need to form the groups, and this is you have up to the end of this day to form a group. Today or tomorrow morning. I guess tomorrow I'm gonna send you like a shared Google document, which allow you in order to choose the groups if you want. So in the shared document, you're gonna see that we have like group 1, student 1, 2, 3, group 2, student 1, 2, 3. Okay. So the only thing you need to say, if you know someone to work with, you can say this is my name, your name, and your email. If you want to work alone, please write a note that I prefer to work alone. So if there's another student looking for someone to work with, if you found those, so this note, they say, okay, this guy wants to work alone, so I don't bother to write my name here. So you can choose whatever group to work with. You can use the Piazza in order to communicate with other students. You can post a request or say a query. I said, okay, my name is blah, blah, blah. I'm looking for a group member to join too. Okay? So again, tomorrow morning, I'm going to send you shared document, Google document, in order to fill, whatever groups you want to join, if you wanted to work in the group. You have up to May 31st. After that, I'm gonna do this one randomly. If you have one to see and doesn't find the group, I'm looking for the group, so I'm gonna do this one randomly. Try to do your best, okay? Try to communicate with the student. I expect from you to have a Git repositories, okay? You are going to create whatever repository. For each student, definitely you do have a repository account at Bitbox. You can use this one in order to exchange, in order to work, collaborate in the class project. I do have what is called the pair and self-evaluation form. You have to fill this one by the end of each phase. When you submit phase 1, I'm going to talk about the phase 1 later. When you cover the theoretical part of the phase 1, I'm going to give you enough time in order to finish phase 1. So assume we finish this one today, I'm going to say, okay, you have up to next Monday or next week to submit phase 1. Once you submit phase 1, it's going to be only one submission per group. You have to fill pair and self-evaluation form. You have to tell me what we have done in phase 1 and what the others in your group members did, okay? So the reason behind this one, I need to make sure that every single group member is gonna work. I know 3 students, maybe they have only by the end of the semester, one student gonna complain, they're gonna say, I was the only one who was working here. I don't want to hear this one. So if you have an issue, we can catch this one early. So at the end of each phase, don't worry, I'm gonna remind you, I'm gonna send an email to say, this is the due date for the phase 1, and don't forget to fill this form, and gonna be available in the Blackboard. So expect everyone gonna fill this one at the end of each phase. Okay, we have only expect from you only have one submission per group member. Okay, so if you have one Bitbucket that you're gonna use or maybe create a specific Bitbucket for the specific group, you have to just send me invitation using my email, and you need only read access to this data. Okay, you need to see what you have done there. The timeline, as I mentioned, I'm going to be explained later during the parts of the class. I cannot set a specific timeline for every single phase because I don't know whether we're going to, at that time, we're going to have enough time to cover the material that require the theoretical things that help us in order to finish this phase or not. So it's going to be later. So anyway, you're going to have first, now we have up to the beginning of next week. If you have another idea, if you don't like the class project, I'm going to post it tomorrow. You tell me about your idea, and you have to get my approval first. If not, then you have to do the same class project. You are going to design database model. Then after that, this phase 1, phase 2 is going to be derive the relational model. Then the phase 3 is going to be implement the application. And this is going to be by the end of the semester. So this is the submission instruction. Don't worry, I'm going to send you email later, but this is very important slide because it's going to give you an idea what my expectation, what the content, what the structure of the file statics or the submission format that I expect from you. The project has only one submission. The final project at the end is going to be final submission. For the phase 1 and phase 2, at the beginning, I'm not going to grade them. I'm just going to give you feedback. Okay, so I'm gonna say for the phase 1, when you submit this one, for example, next week, I'm gonna tell you, okay, your let's say submission is okay, but you have minor issues. You need to fix them. Then you give you a chance to fix this one. Then after that, you're gonna submit phase 2. I'm gonna give you just feedback. Then at the end of the semester, you are going to submit phase 1, phase 2, and phase 3, and now I'm gonna grade all of them. This is gonna be the final grades. Okay. The final submission project is going to be due. This is the last time of day I can give you. Okay, Saturday, July 3rd. Okay, the end of the semester by the midnight. I think you have time. You have to start early. I know the semester is short semester, but I guess the content is interesting. It's not hard. If you understand the content in the class, then the only thing you need just to practice, just to solve the homeworks, etc. Anyway, the class project is the due date. I'm going to remind you of this one. And this is, the project delivers. This is the final one. The AR model, which again can be a type of image. It can be any image file. It depends on you, or PDF or whatever. Because here the AR model is going to be something like this. It's like a diagram. Okay? Something like this. It's going to be only one image. Then after that, the phase 2 is going to be a relational scheme. We're going to cover in the class how can you come up with a SQL script. I'm going to show you a SQL script. How could you build this one? Or it might be going to be simple text file, which allow me in order to create the tables that we have. Which command allow me in order to, we try to simulate your work. I need to create your schema or database to work with. So this one is going to help me in order to create that. Sample data use. I don't expect from you to have 1 million table. Records stored, maybe 3, 4, 5. For example, if you have 3 tables in your relations, for example, student, instructor, and department. So expect we have few students, maybe 3, 4. I expect we have maybe 3 records for the instructor, 3 or 4 records for the department, something like this. Okay, sample data which allow me to test your information. Then after that, the application. I expect for you to send me the source code, of course. Okay. So it depends whatever you're gonna, depends application, web application, desktop applications. Remember, this is not web application class. Okay, so when I'm grading the class, this go to the project grading, then after that go to the video. Okay, the project grading gonna be 75% based on the design. So based on the phase 1 and 2, it was 75%. The final application program is gonna worth actually 25%. So I'm gonna use 5% in order to, depends on the video. I expect from you to have a short video. You gotta have a short demo. Unfortunately, we cannot meet, okay, because the short time here that I have here, so you cannot demonstrate your project. So I want from you just to have a short video or demo that how could you your application work. For example, assume your application requires from the user to have first username and password. So give me like a sample demo or short demo for you, how can your code is going to be executed. You're going to say, for example, you have a username and password. Then after that, you click enter. Then you're going to show you the next slide or next form. Then you're going to show me some insertion, deletion operations. Try to simulate, the task is going to be as described in the course project description. Okay, so the video is going to be worth 5% here, and the 20% is the way how to implement your code. For example, if you give me the source code that's never work, never command or compile, then you're gonna get 0 in this case. Yeah, if it works, then in this case you're gonna add up the number. Clear? That's all about the class project. And again, during the course of the semester of the class, I'm gonna remind you, for example, this is the phase 1. That's what I expect from you. This is the phase 2. That's what I'm expecting from you. This is the phase 3, the final delivery. That's what I'm expecting for you. There's the following that I want from you to submit. Okay? I'm going to give you like grading guidelines for every single phase. So at least you're gonna expect how I'm going to grade your each phase. So it's gonna be the grading criteria is clear for you. So I'm gonna, let's say when I say the due date of the phase 1, for example, next week, and this is the grading criteria or guidelines that I'm gonna follow in order to grade phase 1. So you know exactly what I'm looking for. Okay? Everything is gonna be covered in the class. So it's not, it's not a challenge, okay? It's not tricky questions, or I'm here just to try to help you to make sure that you understand the database system. You understand how to start from the scratch to build the database application, okay? And also how could you use, say, SQL query language in order to achieve, manipulate the data in the database system. That's my goal here. So far, so good? Okay, good. The late assignment, try to do your best in order to submit whatever the class project or the homework at the due date. If you need time, just reach me out. But keep in your mind that if you give you an extension, the problem we do have like for assignments. If you give me an extension, that means I cannot shift the next due date with the next assignment. You see that because now we have 6 weeks maximum, I guess. So almost each week I expect from you to do something. If you cannot do this one this week, I can't give you more than 1-2 extra days. Because if you give me more, this means you are going to force me to shift the due date of the next assignment, which I can do. So try to do your best. If you need extension, just let me know. Okay? But please don't wait until the last minute. I say, I can't finish. I just started some emails, or some student just sent me emails who said, okay, I just start working in the homework today at the due date. Then I realize that I don't have time to finish this one. Please, could you give me an extension? I mean, yeah, I'm your side, guys. I'm gonna give you extension, but I'm gonna add one mark to the student and say, this guy maybe is not serious because he was just started the last day and you're looking for extension. I don't like it. Anyway, try to do your best. Please don't copy those answers from another student or from an online or whatever, any other resource. Do your best. Try to answer the query, because the goal here, as I mentioned here, it's not worth trying to find someone else in order to help you. Because as I mentioned, I'm trying to do my best in order to make sure that you understand the material that covered in the class. And all I need from you to try to apply whatever you learn in the class in order to test your knowledge. And remember, this is a database course. So later, when you graduate and you work in any company, and they know, take a look at the CV, you get A in the database organization. Then they try to ask you to please build a system, or maybe you need to analyze the system to add more functionality. And they said, I don't know. So that's why I said, please try to do your own work, okay? Try to apply whatever you learn, and this is your chance in order to understand, to see whether you understand the material. If not, reach me out, okay? This is what I talk about the class project. I expect from you to inform me immediately if you try to work in the class project with the team members and your teammates or group mates that didn't participate, they didn't care, then please reach me out. Don't wait until we have the end of the phase 1 or 2 or 3, or write the, let's say, peer and self evaluation form. You can inform me directly. And I'm going to reach the other students or the other group members in order to make sure that this is what happened. Then if we have one student or a few students didn't do anything, they're going to get 0 on the class project because they didn't do anything. So don't assume that as long as you work in the class project, you're going to get the same grade as other class members. No, if you don't work, you're going to get nothing. If you work, you're going to get the scores. Okay? The text bucket we're going to use here, this is a database system concept. I'm going to cover everything in the class. But we are going, if you take a look at this link, by the way, database book, let me write this one here. I guess I can go over this one here. This me, just to show you what I expect, what I want from you to take a look here with this book here. Okay, so if you take a look here, I'm looking for the 7th edition. This is the 6th edition, okay? If you click over this one here, you're gonna see this, first of all, here, the slides. This is similar to the slide that we covered in the class. Actually, I add more extra slides to make sure that this cover the exact material that I'm planning to cover in the class. Okay? But mainly it's gonna be this good, reference if you want to learn more. Okay? So this is the first one. Take a look at the slides. Here we're gonna use this one for the some solutions for the practice exercise. You're gonna take a look, for example, when you cover the introduction part, the first one here. For example, give you some exercise and some solutions. Okay, so that's good practice. So it looks like you have some questions and some exercise, solution with these questions. So it's gonna help you, for example, for the SQL here, give you like SQL command, give you like a database, specific database. Then you're gonna ask you some questions, and you're gonna see that there's a question, and this is how can you write this query. So this is good practice. It's easy to follow, easy to understand, and easy, or to say, extra resource to cover the material that we cover in this class. We do have another link. We're going to use this one later when you talk about the labs. Okay, so one of them, you're going to use this one later here when you download the Postgres. We're going to use the university database, which is going to be as the database described in this textbook. Okay, here you can use the way that how can use data definition language. You're going to show this one later, which is the way that allow me in order to create this. Take a look here. Oh, you have to download this file and etc. Anyway, this file was a script or SQL script file which contains the commands allow me in order to create the database. Okay, we are going to show you how to do this one in the class, so that's good practice. So this one allows you to use the database system. So the only thing, once you follow the steps, I'm gonna provide you with the way that how can you set up the environment or the lab environment, or how could you download the Postgres in your computer, then how create the database, which in this case is going to be university database, then how populate this database with the data. Then after that, you're starting working, perform some SQL queries and statement in order to figure out to see or practice, okay? So this is the textbook here. And I guess maybe they have some online chapters if you want. Actually, if you Google the database system concept 7 edition PDF, you're going to find or download, it's going to be available online as a PDF file. Don't buy anything. It's available online. Unfortunately, I cannot give you the PDF file because it's going to have a problem with the copyrights. I cannot give you the link where can you find the PDF file. I think I need to remove this one from the recording, but just Google, then you're going to find PDF file. So whatever we cover in the class, if you cannot understand me or if you want to learn more, you're going to see that the textbook is going to have more details. Okay? So I will start talking about now, this is the class organization. Do you have any questions? If not, so the class is from 1 to 410, okay? So what I'm planning to do here, I'm going to divide the lectures into 2 parts, okay? The part 1 is going to be from 1 up to 2:30. Then we are going to take 15 minutes rest. Then after that, from 2:45 up to 4:10, okay? So 2 parts, part 1 and part 2. I believe this is a good idea, okay? Because for me, I can speak for 2, 3, 4 hours without stop. Okay, but I need to make sure that you have 1 hour 30 minutes. Then after that, you take a rest for 15 minutes. It's a good idea because you need to refresh and you can start looking or jumping to the next part of the lecture. Okay, so from 1 to 2:30. Then after that, from 2:45 up to 4:10. That's the structure of the class. Okay, so once you start and talk about the database here, let me first, define what do you mean by the database. Now we're starting database. Tell me, what's database? Database is defined as the following: is the collection of data that is related together in some way, that's trying to model some aspect of the real world. So that means in this case, this data is usually related and have some common to them. That's the definition of the database. In general, let me give you a simple example here. University database, which contains information about the university. So it looks like it's like the data is related together. So here in the university database, you're going to find information about the student. And you're going to find information about, the instructor. And information about the staff. You see? All the information. And you're going to find information about, courses. And the relationship between all these somehow is connected. You see that for the student, what the relation between the student and the course? The student takes course. Yeah. What the relation between the student and instructor? Besides that, the student hates instructor. Take a class with. Or instructor is going to advise a student. You see that? So all the information can be related. So in this case, you're not gonna find information about FBI agent. Is not related. So this information is not going to be a part of the university database. So all the database, that means what? The collection of data that is related together in some way. And this trying to model some aspect of the real world. What we have in the real world, we have a university organization. So we need to have a university data system. So we need to, let's say, model somehow, but the information that relates in the university, and let's say a set of tables, for example, on the relations. Make sense? The database are what? Is the core component of the most computer applications. I didn't find any application, mostly, it's rarely to find any computer application that doesn't rely on the database at the backend. Right now, when you log in the Blackboard, when you try to log in to say to the My IT portal, etc., somehow the backend there is a database that contains information about the student. When you try to log in and provide username and password, somehow there is you need to consult the database or file that contains the credential information associated with every single user in order to confirm whether you are allowed to access the system or not. If you use your mobile phone or whatever, Google Map, etc., somehow there is a database backend at the end. Because the Google servers, they have like a database, a huge database, a spatial database that contains all information about all the locations, possible locations, etc. You see that database is everywhere. So that's important to understand, it's important to read the database, okay? This is the database. So what's the database management system? Oh, what's the database system in general? Database system is defined as what? Is a collection of interrelated data. As it's going to be the data that defined as a database plus something else. So this is a database management system. We use something like this. I'm going to have like a database, for example, university. It maybe have database like banking, okay, bank online or whatever, different databases. It might be one or more database. Plus, it's going to have what? A set of programs or software which allow us in order to access this data in more efficient and convenient way. This is the most important thing. So again, it contains a database plus a set of software or programs which allow us in order to access, manipulate, modify the data in an efficient and convenient way. This is the most important thing. So what's the examples of the database management system? An example of the database management system is going to be MySQL, Postgres, SQL Server, Oracle, a lot, too many, okay? So why the database is important? Why someone will say, okay, why do you need database management system? Okay, or why the database is important? By the way, when I said database system or database management system, I mean the same thing. So the database management system is equivalent to the database system. Okay, when I've said only database, that means I'm talking the actual data with the collection of the data that relate together in some way. When I've said database system or the database management system, is going to be the one that the big thing that contains the database itself plus a set of programs or software which allow me or allow us in order to, let's say, access, manipulate, modify the data in a more efficient and convenient way. Okay? The primary goal of the database management system or the database system is in order to provide a way to store and retrieve the data information that's both convenient and efficient, and keeping saying convenient and efficient. And there'll be more details later. What do you mean exactly? Why I'm emphasize this one? So what the database system do for us? Provide persistent storage, a way in order to store the data, permanent storage of the data. Well, of course, we expect that the place that we store the data is not compromised. No one deletes the content of the database. So when you store the database into the database management system, when you get back tomorrow, maybe a few months later, you can be able to retrieve the data because it's going to be permanent stored. Okay? It provides us with an efficient declarative access to the data, which is going to be covered when we talk about the query or the SQL query. Okay? When you say access to the data, definitely you're going to perform query. What do you mean declarative here? So declarative, we're going to see later. I'm going to say, I want just give me this piece of information. Let me give you an example. For example, I want to select all the information from the student relation. I will list all the students, for example, enrolled in the IIT. So I need to say select, you're going to see later, star from table student. Okay, so what I've said here, I just show you the system is saying this is the information that I'm looking for. I need all the information that is stored in this table. Did I specify how the system is going to execute this one? No. I didn't tell the system how can he or it can get the result. I just specify the way that or what I need. This is the result that I need, and good luck. Figure out the best way in order to execute to give me the data. That's why we call this one declarative access to the data, or declarative language. I'm going to talk about this one later, more details, but just to keep your mind right now, we do have some, let's say, advantage what the database system is going to do for us. Also, there is a protection against or from the hardware software failure. The database-based system, in general, will provide us with a way or mechanism that if the system is crashed, we're still being able to recover from this error. Or if the hard disk, for example, where I'm going to store my data is going to be somehow not being able to use it or to get access to, we do have like some archive or some, let's say, redundancy or some mechanism allow me in order to recover the data. Okay? And also safe concurrent access data allow provide me with a way that if we have a multiple access, user try to access the data simultaneously, we're gonna have to provide a safe environment. Yeah. So in this case, if we give you an example, assume that A and B try to modify the piece of information X. For example, B wanna add 100 and A is gonna take 100. Or let's say both of them try to take $100 from this one. So after this interaction, we expect the value of X is gonna be 800, right? But here, if we don't have a mechanism here, does the database allow me to have a mechanism that both of them can access the data and end up we have the right result? That's what's called the safe concurrent access and more. Make sense to you guys? Any questions? Good. So who uses the database? Everyone. I don't want to go with more details, but anyone, everyone. Let's say most big software system involve database. You, as a desktop software or the application that we have, your email client, you have, say, use your music players, or say, most of the applications, I'm gonna say not have, let's say most of the application in your phone. Every big company, for example, banks, insurance, government, Google, whatever, Facebook, social media, etc., they have it, they use the database. So who produces the database system in general? Who's the one going to produce that? We do have a different types of database systems. The simple one is called the traditional relational database system. We're gonna be more clear today when we start to talk about the database. I'm gonna introduce you, show you what do you mean by the relational database. But I mean, to simplify that, we can say the database model is gonna be store the data in relations or as tables. That's what is called the relational data model or database system. For the IBM, they have database 2. For the Oracle, they have Oracle. For the Microsoft, they have SQL. They're open source. It's going to be MySQL, Postgres, and etc. We have many options here. Okay. There is a distributed system with the database characteristics and the big data. Well, I'm not going to cover this one in this class. We do have, I think, we have distributed database system class offered by Professor Pross. I don't recall the name, the exact name, and the big data. So that class is going to cover this more details, the distributed database system. So mainly in this class, we're going to, since it's just introduction to the database system organization, we're going to be cover the traditional relational database system. So the question here, why you are here, why you want to study the database class? I know you didn't have a choice because as an undergraduate student, you have to take this course as required. But just be able to come up with the way that why we need in general study database, why do we need to learn about the database. Database is gonna used to be years ago, I mean decades, only specialized applications. Right now, it looks like it's gonna be database is a central component in most of the computing environments. And most of the application, I'm not gonna say all, but most of the application is gonna have what? Gonna have involved back-end database. Somehow at the end of the server side, they must get involved to the database, must get access to the database somehow. So the knowledge of database concepts is essential for the computer scientist. As a computer scientist, you must know, the basic of the database. So the field of database has a number of contributions in different fields, computer science. When you go over, for example, AI, machine learning, and such an operating system, definitely gonna find somehow database. Okay, the database can be applied to the different problems in different areas. The database management system software is like highly successful as a commercial technology, and also database research are highly active and very interesting. That if you wanted to continue your study in the database, this is the best reason that I found. Background in the database make you competitive in the job market. It's interesting you have a CV inside this one, I'm familiar with the different database of how to use a SQL and how to connect the data, which allow you. I found many, I know that many students, after taking this class, of course, they must have knowledge about the web application, etc. By combining their knowledge, get easy job to work as a software engineer or web developer in this case, because they know mainly how to use the database, how to connect the database. So the class project is going to help you at least try to do your best in your class project. Then after that, try to continue working your class project and enhance this one. Doing the class project is going to help you in order to how to build an application which is going to be ask the database, modify the database, which is going to be similar to any application you're going to build. Of course, in the future, maybe going to be more complicated, but this one is going to give you an idea, give you like a certain degree that you are going to be able to finish this class or do this one. So what's this course and what's not? It's not, I'm not going to be tutorial. When I say tutorial on specific database management system, although I'm going to just show you that when you talk about the SQL commands or statement in general, I'm going to show you the standard SQL, which is going to be everyone that follow. Then I'll just give you an example since I'm the big fan of learning by doing. So we need to use or apply whatever we learn using specific database management system. That's why we're going to use a simple one with the Postgres. You can apply whatever you want. If you have, let's say, using different database, MySQL, whatever, you can test this one using different database management system. But here, it's not going to be a tutorial, for example, to show you how exactly to use the Postgres. We use the Postgres as like a mean in order to understand the material, in order to just practice what we cover in the class. Okay? It's not tutorial in the SQL. Although we're going to cover SQL statement, but it's not going to give you every single possible statement commands in the SQL query language. I give you the most common one. Okay, then later it depends on you. If you want to learn more, that means you need to spend more time. Okay, and as I mentioned, this is a class, not because I'm teaching this one, but I like this class because it's easy to understand and you're going to see the benefits of this class. So I'm not going to teach things that you will never use. No, definitely you're going to find them. You're going to use them. Okay? It's not a course on the database implementation. So I'm not going to show you how to implement database system. Actually, we say database here. I'm talking about the database system. Okay? Or the database management system. We are not going to build or implement the database management system. We are not going to build or create an application or say something similar to the Postgres or MySQL. We cover this one in CS525. We try to give the basic knowledge with the students in order to help them and give you like a baby steps how they can build the database or implement the database management system from the scratch. But you will learn the foundations, database design, which is the most important thing. You have like description for the project or application that someone hire you. Then after that, you are going to design the database. Then after that, you're going to use some SQL. I say I'm not going to sum with you many SQL commands or statements and the relational algebra. Then after that, how can we use a database? When you use a database, you can perform create users, etc. How can you use the database? How to add tables? How to modify the data? How to alter, modify the structure of the database? How to insert, modify, manipulate the data, and etc. Okay. I think combining this course with the software engineering can be a great idea, which you are going to. You don't have a choice. It's for the undergraduate student. You have to take these courses. So both of them are going to help you a lot. Hopefully. If it's not, please send me an email later or tell me whether I'm correct or not. So you will, how could you use this material, or when we're going to use this one? Generally speaking, when you build any software application that involves somehow database, the backend. Okay. So that's all about the first part. This is the introduction. Okay. Do you have any questions so far? Good. So now we're done for the first part. Now let's take a look to the relational data. I mean, actually, sorry. We're done for the first part, which is called the course organization. So now I'm going to cover the introduction to the database, or introduction to the database management system. Okay, with the second part of today's lecture. You already have access to the material that's available on the Blackboard, yeah? Okay. So introduction here. So this is, if you follow me with the textbook, this is chapter 1 of the textbook, with introduction to the principle of the database. So I'm going to introduce you to the principle of the database management systems. I'm going to go over the architecture of the application that use the database as their backend. Okay, so what I'm planning to do here, we take a look. What do you mean the database? More details. Database, so we define them. Database systems or database management system. I'm going to talk about, give you some few applications of the database system. Then why we need a database system or database management system. Why we need to use, for example, Postgres, SQL, MySQL, etc. Oracle, etc. Why we cannot rely on the file system in order to store my data. Then after that, they're going to show you different ways in this, we call the different level of abstraction, which allow me in order to view the data, make it, you're going to see that the database is complex, database management system, complex system. So there's many complexity, we need to hide them from the user. On the normal user, there is no need in order to know exactly how the database management system component works, what they're exactly doing in the lower level. So we have a level of abstraction. We call this one the view of the data. I'm going to cover this one more details. Then take a look to the different database language in general, define them. Then after that, talk about the database design. Just introduction for this most of the part that we are going to cover during this class or during this semester. Show you different design, database design, database engine, how the database component looks like from inside, database architecture. Then after that, we're going to take a look to different users that can use the database. Then history of the database system. When I reach this slide, I'm going to spend maybe less than 50 seconds because I'm not big fan to talk about the history. It does make sense to say 1950 we have database 1, then 1970 we have database 2. So we'll see that when you reach the slide, they're going to say this is the history database and see you next week. Okay, we're still in the class, by the way. So anyway, we define the database, yeah? And we define the database management system. We define the database as what? As a collection of the data that is related together in some way. That's trying to model some aspect of your world. All right? So again, we said the data is usually related and have some common to them. As example, we said that the data might be, let's say, university database, which contains information about the students, course, faculties, and etc. Okay? Ignore the entity and the relationship right now because this is the way that how can you use in order to model the data. Assume that we have a set of tables, these table entities, and each entity is going to have what? Somehow it's going to has a relationship with another entity set. For example, the relation between the student and the faculty, for example, the course, we see that the specific student is going to take a specific course, yeah, or enroll in the course. This is the relationship between them. Typically, this data is going to be shared by multiple or many user programs. Okay, this is the database in general. So what's the database management system? The database management system, again, we covered this one a few minutes ago, but it doesn't hurt if we go over this one again. It's defined as what? A collection of interrelated data. So it's going to be database that we cover, for example, university database or maybe multiple database, okay? Plus a set of software that allow us, or programs that allow us in order to access data. When you talk about the access data, that means the primary goal here, in order to do what? For the database management system, is going to provide us with the way that to store, manipulate, or gear the data or database information that is both convenient and efficient. Must be convenient and efficient. Okay, so a set of programs or whatever software. It's fine. Database systems are used to manage collection of data that are usually, most of the time, highly valuable, relatively large. Okay, and it might be can be accessed by multiple users. Okay, or multiple applications, often at the same time. Right now, we have few students that ask the blackboard to this class. So how the system is gonna manage this one at the back end? Yeah. So the first database application maybe has a simple structured data. In early days of the database, we don't have a lot of data and we don't have a lot of attributes in order to build the database system that we have. Okay. However, the modern database system is a complex software because it's what? It's gonna tasks that manage a large complex data or collection of data. So when you talk about the modern database or complex software, or in order to manage this kind of complexity, it's not easy job, okay? And the key in order to manage this complexity is what? The concept of abstraction. You know what you mean by abstraction, yeah? Abstraction, I give you like a definition here, is allow the person to use, say, complex device or system without having to know the details of how the device or system is conducted. Give you a simple example. You're driving a car, yeah? So person or anyone is able to drive a car. What do you need to know in order to drive the car? You just know only how to operate its control. You need to how to turn left and right, how to go forward, how to go back. Yeah? So that's what we need to perform for that, okay? The driver or the person who drives the car doesn't need to know what? How the motor, for example, was built, and also know how it operates. I don't care what's gonna happen after I put my key in the ignition, unless you're a curious person. But when you turn or drive the car, the only thing you need to know how to drive it. I don't care what's going on beneath this one when you turn on. Because what? It's like a level of abstraction. Everything is high. This complexity of how the motor is gonna be ignited or gonna work, it's gonna be operated, it's gonna be wired, it's gonna be hidden from the normal user to make it easy to use. That's what's called the abstract. Okay? So, management complexity, the concept abstract in the database management system is going to provide us with the abstract of the view of data. So what does that mean here? It's going to hidden a certain, say, element of how the data can be stored and manipulated. For example, when you log in the database right now, or log into your, let's say, email, okay, account, at the end there is a backend database, right? So do you know exactly how your data can be stored in the server? No. Do you care, for example, whether your data can be stored in one server or multiple servers? No. Do you care, for example, whether, or do you know details about, to say, more, in this case, better to formulate that like this. Do you understand or know exactly how the data is going to be formatted, lower level can be stored in the disk? No. Whether it can be stored next to each other, or it can be spread over different servers, whether it can be stored in one block of the data. If you're familiar with the operating system, you know exactly the data in the lower level of the file is going to be blocks stored in the lower level of the disk. Okay, a set of blocks is going to be, or sequence of blocks is going to be store information that relates to one file or set of files. Okay, either it's going to be next to each other or it's going to be randomly, let's say, stored in different places in the lower level. I don't know, for example, how, for example, if you have information about the student, you have the ID name and the password, something like this. For example, ID 123, the name is Alice, and the password 1234. So in the high level, as a user, when you select the information of the user, you're gonna get the ID, the name, maybe you're gonna get the password, and whether allow user to access the system or not. But I don't care this piece of information, how this data is gonna be stored in the lower level. I'm not interested. I didn't need to know this one. This kind of information can be hidden. That's why this is what is called the abstract view of data. It's gonna hide, you see, certain elements of how the data can be stored and manipulated in the lower level. Otherwise, if we don't hide this piece of information, this means anyone who tries to access or work with the database management system must have expert in the database management system, because must know exactly how the data can be manipulated, stored, and set up, which is not convenient for the most of the user, because most of the user are not database or not, let's say, computer science expert. And there's no need to know this one. And the simple example analogy with this example for the car. You need to know that how to operate the car, how to control the car, but you don't care about to say, no, you are not interested. No, there is no need in order to understand how the motor of the car exactly works or operates. Yeah, makes sense. Awfully. So this is just an example for the database applications. Database everywhere. I'm not going to go over slides more details, but just to see, for example, the university. They have like student information, course registration, grades, etc. of the database. That's one example of the database. Banking. The bank will have like a database. This kind of contains information about the customers, the transactions, etc. Yeah. Let's say enterprise information, manufacturing, credit card, finance, and etc. And all this back to the databases or the computer systems. Most of them are going to have, or most of them, or all of them, they must have, let's say, backend database somehow. Web-based service, for example, social media, all of them, they have a database. One kind of application, or one example of the database application. So as a list, to go over this one, you see that this list is going to tell us that the database formed an essential part, and not only for every enterprise, but also large part of the person's daily activities. So database is everywhere. Good. Why do we need to have a database system? Maybe someone has said, what do you need here? You have the data. It looks like we have a tables, so I can store my data in the files. And they can use the file system in order to store the data. Then after that, we can build a set of software using Java or Python, whatever, which allow me in order to access the data, right? That's one thing maybe you can think about the database. Sorry. Yeah, I'm getting worse, by the way. The cold is getting worse and worse. Hopefully you can manage to finish today's classes. So, as I mentioned here, I'm going to try to convince you that we need to have a database management system, okay? We cannot rely on the file system in order to take care of the database job or the task that you try to perform here. So in the early days, database application fell directly on the top of the file system. So in this case, if you have any system, you assume that we have information about the student. I can have, let's say, or different departments. We do have a computer science department. I'm going to create a file, text file, for example, or whatever file, or binary file, for example, using Java, or then, or text file. Then here it contains information about all the students in the computer science department. Then we have another file which contains all the information about the student in the math department, etc. That's one way in order to organize my data. So I'm going to use the text file. I don't care. I don't want to use SQL. I don't want to use, say, database management system. That's the way how to use the data in the early days, using the file system. Then, it looks like you have a permanent record. It's going to be different, so stored in the various files. And we need to have like a set of different application programs which allow us in order to access the data. For example, if you wanted to access or collect or select or produce, say, a list of all the students in a specific department. So we can use or create Java application, right? That's what we did in CS 115 and 116. You have the data stored in the files, then you can write the Java code, which allow you in order to retrieve the data from the file. What you need to do here, I need to know the file name. I need to know the structure of the file, how it looks like. For example, what's the first, for example, we have an ID, we have a name, we have a GBA, and more information, address, etc. So we need to know the structure of the file. Then I can write my Java code, it access this file, and it's gonna retrieve the data. Either it's gonna be displayed or printed out or put in another file. All right, so far so good. So this is a simple way to perform that. If you have a new application program, for example, you're gonna add, gonna be added to the system as needed. Right. What does that mean here? So in this case, if you have, I want to extract, say, a piece of information. I don't have a code or application or periodic application or Java code which allow me to achieve this task. So in this case, I'm going to hire someone else, let's say another programmer language. Maybe we built the system in 2000, then in 2005, we need to say what? We need to extract another piece of information. I checked all the programming applications that we have on Java codes. I didn't find any Java codes that allow me to perform that. So in this case, we are going to hire someone else. Maybe that guy worked with a Python, not Java, and is going to write another application which allow me to access the data, then give me whatever I want. So in this case, it might be have a case that new application programs will be added to the system as needed. Maybe you have or require from you to build, say, new application programs which required in order to handle new rules in the universe or in the system that you have. Maybe you said the students are not allowed to have more than two, let's say, majors. For example, 3 majors. Oh, the minimum number of course students can register per semester must be specific value. Or we change the GPA. We don't. Our GPA is not 4 points. Maybe it's gonna be 10 points system or 5-point systems, something like this. So in this case, you need to do what? If you don't have these rules, one application program, that means in this case, you are going to create another application program. Yeah, right? Java code, Python code, in order to allow you in order to perform this operation. Okay? So what we did here in order to make sure that this file processing system is not a good idea. So at the lower level, we rely on the file or the operating system in order to take care of the file, right? So the operating system when I create the file, say computer science text file, the operating system gonna take care of the way that how the data can be stored on the disk. Every time we need the data, I'm gonna rely on the operating system in order to fetch the data, perform the task that I want, then I'm done. Okay? To simplify the process here, and to make sure that to convince you that the file processing approach is a bad idea, that means there is a need to have a database management system. Let's generalize the data that we have. Assume that we have a university database, okay? With a part of the university database that keeps information about the instructor, the student at department, and the list of course offering in this, okay? We are going to keep the stored information in the operating system files. So in this case, you're going to text file, CSV file, whatever, document file, whatever you want to store, binary file, etc. Okay? And we do have a list of applications available. Allow me to add the new student instructor courses, maybe register a student for the specific course, etc. Maybe assign grades to the student, compute the grades, GPA, and etc. for the student. So we have a list of programs. Is clear so far? So good. Hopefully. That example that we have, now we're going to rely on the file processing approach or system, or the operating system file, or file system, the operating system in order to take care of this file. And now I'm going to convince you that this is a bad idea. We cannot do that. So the first thing, there's a major disadvantage. The first one, data redundancy and inconsistency here. So remember what we did here. We did have a different programs, maybe create the files and application programs over a long period of time. Remember, we built our system 2000, then after that, 2005, we found out that we need to add a new rule, or maybe we need to extract other piece of information which we don't have a programming available. Or they say application code or programming code application available for us in order to use in order to extract this piece of information. So in this case, we try to hire either the same one or the same guy that we hired maybe 5 years ago in order to create our code, the code in our application program in order, or Java code or Python in order to give me a piece of information that I'm looking for, or I'm gonna hire someone else. So remember that this is based on experience, okay? I used to teach CS 115, 116, or 201. And every time you ask your student and give them the specific instruction, you expect from you to create this file that contains the following information. Okay? So every student is gonna have like its own way in order to organize the data. One of them, for example, is gonna put the ID, the name, then after that the GPA. Another one gonna have the name, ID, then the GPA. The start will be different. You see the way how to organize the data within the file, it's gonna be different from one person to another person. And the same thing here. Since we have the data gonna be stored in multiple files format, because you have maybe you have a multiple user, multiple programming developer user in order to build the system here. So there is a chance here that we have each of them has its own way in order to organize the data. Okay. In addition, maybe we have same information can be duplicated in several places. So assume that we have one student. Now this student is going to be in the computer science and also in the math. So we have a double major. If we assume that we are going to store the same information for every single department, they'll be in the separate file. So this file is going to contain all the information about the student in the computer science. And we have this file, another file that contains all the information about the student that belongs on the math department. Assume that we have some personal information, say address. Okay, so this is going to be address, and this is address. For the student ID here, 1, 1. So the same student is going to have repeated information here and here, right? Because the student have a double major. That's one thing. Assume that we have another problem. Data might be duplicate or we have inconsistency among the data. What does that mean, inconsistency? So if you try to modify the address of the student, so you need to ask for every single file for this student, every single file that belongs to every single department that we have here, and for every single file you need to search for a specific student, and for this student you need to update, for example, the address. There's a chance we're going to make a mistake here. For example, I want to modify the address of the student ID1, which is the one that has double major. Maybe I made a mistake just to check this one in the computer science department. I've now found that this is the main major for the student. So I'm going to update the address here for the student. For example, from Chicago to Naperville, for example. Okay, this Naperville, and this one is going to be stay in the Chicago because I don't change this one in the math. Now we do have an inconsistency in the data. What does that mean in this case? This means we have a various copy of the same data may no longer agree. So in this case, if I ask you, give me the address of the student ID1. So now we have the address in Naperville, for example, and we do have another address which states the student in Chicago. That's what is called the data inconsistency. That one's going to happen here. Okay. We do have something else. The other problem here is called difficulty in accessing data. As you measure, sometimes you have a new task you need to perform here. You check whether you have any programs already there or not. Remember, those are the programs, a set of, let's say, Java codes are available, which allow me in order to extract the information that you're looking for. But sometimes you're going to add up a new task. So you need to perform something new. I didn't find any programming existing program in order to perform this one. Either I'm going to hire a new one, and now we might be the problem that that guy is going to have a different structure because each one is going to have its own way in order to create or access the data. Or maybe you're going to do what? For example, I want to list all the students that are located at specific zip code. So it's easy to find this one, yeah. If you don't have a code or the program is going to perform this one, either hire someone to write the specific code, or I'm going to find all the lists that in the specific department. Then after that, I'm going to do this one manually extract the information that you're looking for, which is going to be only locate, the student there, or they'll have the specific zip code. For example, you add something extra. I want only the student, the computer science department, they have like a specific zip code, and the number of kids never exceeds specific numbers. So again, we have the same problem. If you don't have a specific program to take care of this one, either I'm gonna do this one manually or hire someone else in order to develop it. It does make sense. So in other words, there is no high-level query language, something declarative language like SQL, which I just type my query and the system tried to figure out a way in order to extract the information that I'm looking for in a more efficient way. Data isolation here. What do you mean the data isolation here? Since they have here, the data are scattered everywhere, okay? And various files in different formats. Okay, so we end up we have multiple files and formats. Yeah, for example, I hire one programmer or developer which is going to use, for example, Python. Another one is going to use a Java, and each of them, for example, some of them require work with, say, with binary files. Another one maybe going to work with text files. So each of them has a different format, and within, if you use the same format, each of them has its own way in order to organize the data within each file. So you have multiple files and formats here. So this means in this case, we don't have a data isolation. That means my programs is the data dependence. So in order to write my code, in order to access any files, I need to know the exact structure of the file. You see that? Because, for example, you need to extract the first field, the second, the third, etc. Okay? So in this case, I need to know what exact the next field, what is exact the second field, or the second column, and the third column. Whether it's going to be ID, name, and GBA, or it's going to be maybe ID, GBA, and name, or maybe it's going to be name, ID, and the GBA. You see the different structure. That's what's called the program is going to be data dependence. This piece end up we have high maintenance costs. If you try to modify the data, access the data, you require from you to understand all the structure that we have, all the different file formats, which is not an efficient way to do that. Integrity problems with another problem. I guess until this point, you're going to say, okay, I think you need something else. This bad idea if you rely on the file system in order to take care of for the job that require database management system is supposed to do. Okay, so what's the integrity problems here? So the data values stored in the database must satisfy, say, certain types of consistency constraints. I'm going to cover this one in more details. Okay, but keep in your mind something like this. For example, one constraint that we need to achieve here, we call integrity, or maybe sometimes you call this one domain constraints. This means you can say for specific value, never exceed or must be in specific range. For example, the GPA must be between 0.0 and less than or equal 4.00. So this is the valid value of the domain constraint that looks like a set of rules, or this attributes must satisfy this condition. Or the GBO, the account balance must be greater than 0. Or when you try to deduct specific amount from the balance must be, this one's going to be less than or equal the exact balance. So you're not allowed to take more than whatever you have in the balance. For example, my balance is $100, and now I need to deduct $1,000. So the system says, no, you cannot perform this operation. The balance must be greater than 0. Your balance is not allowed to go below or has a negative value. Your GPA, again, as I mentioned, must be, say, greater than or equal 0 and less than or equal 4.0. So the GPA 5.00 is not valid entry. That's what you call, integrity problems. Okay? In order to enforce that, I'm going to do what? If I give you like a condition here, so that means you are going to bury this one inside your code. Remember what you did in the CS116. If I said, for example, make sure the balance must be greater than 0. We are going to enforce this one. You are going to enforce this one when the time that at the moment, if you build the classes, when someone tried to modify the balance, then after that you need to validate the entry or the input, whether it satisfies this condition or not. So you're going to hard code this one in your code. So what if I said we change this one? Oh, let's go with the GPA. Actually, the GPA is nice or interesting. In the GPA here, so in your code, you're going to say, make sure the GPA is between these values. Okay? How about if we said the GPA is going to be, instead of 4 points, it's going to be 5 points. So, of 10 points. So now we change from 0, let's say, the lower bound up to, say, 10 or 5.00. How can I do that? That means I need to go for every single code, programming code, in order to modify this one, which is going to be tedious job. It's not inconvenient, right? A time steal of updates. Okay, so I will stop here. Okay, so because now it's 2:31, so I will back to say 2:46. Okay, let's take a short rest and we continue our class in 15 minutes. Okay, see you in 2:46. Okay, welcome back. So we're going to continue our discussion about why we cannot use a file system to store the data, instead using the database management system. Okay, so I guess we reach the, let me check here, I think, yeah, check the problem, yeah, atoms to the update. So what does that mean in this case? Generally speaking, a computer system, like any other device, is subject to let's say, to failure, okay? So failure may leave database in inconsistent state with partial updates carried on because we don't have any recovery mechanism. So let me give you an example here. Assume that you want to say transfer a banking system where you want to transfer, let's say, $100 from account A to B. Okay? So in order to perform this operation, what we're going to perform? You're going to perform a set of operation. Okay? It'd be, I think, just go to the whiteboard here. It'll be much easier to. So I want to transfer from A to B $100. So first I want to take a look to the balance of A and equal minus equal, let's say, $100. So you deduct $100 from this balance A. Then after that, you're gonna go to the balance B, you fetch balance B, then after that you add, let's say, $100, let's say plus equal 100, something like this. This operation you gotta perform here. What if, after I deduct $100 from account A, the system is crash here at this point? Based on the file system, I don't have any mechanism to recover this error. So the data is going to be inconsistent state. So what does that mean, the consistent state? The data is going to be in one stable state. So our consistent state, for example, in this case, before do this transaction, A plus B is equal a specific amount of data, say $2,000. Assume $1,000 in A and $1,000 in B. This is one consistent state. And the second consistent state is going to be here, A plus B still is going to be equal to $1,000. Or you can say in this case account A is equal 1,000 and B is equal to 1,000. Then after you perform this transaction, account A is going to be 900. Then account B is going to equal 1,100. Right? This is the two consistent states that we have. But after I perform this transaction, I didn't finish all the operation here. I just the operation partially done because there is a failure here happened here. So I wasn't the balance to the balance B of the account B, the value that I just detected on account A. So in this case, we do have an issue here. So can I recover from this error using the file system? No, because we don't have any mechanism in order to catch this one. So there's one problem. That's what's going to be the atomicity problems here. So the solution of this one, if we manage to have to do the following here, like an atomic operation, that means I can specify somehow using database system, later we're going to see this one later, I can say those set of operations must be executed either together or none at all. Or not at all. Okay, either it's going to be entirely going to be executed or happen together or not at all. There is no partial execution of this set of operations because I'm going to consider them as one unit or as an atomic. But in the file system, we don't have this luxury. We cannot do that. Okay, so that's another problem here. The other thing, concurrent access by multiple users. In order to have the better performance of the system and the faster response, many systems allow to have multiple users try to access the data at the same time. Yeah, it does make sense if you have a multiple users try to access the data, and you just say, no, you have to do one at a time. It does make sense, okay? Because it's gonna end up we have a degraded performance here. So, uncontrolled this concurrent access data maybe lead to the inconsistency. Let's use a file system. You do have a file here, and you have a multiple access file. Each example user A and B, both of them simultaneously modify the data stored in this file. We end up having a problem here, yeah, if you don't have well worked on this kind of operation. So if you take a look here to see we'll go back to the whiteboard here. Assume we have account A here, and we have, let's say, user B here. Both of them gonna just say modify, let's say, the value, okay, that's stored in this account. So assume the value X is 1,000. For example, A is gonna take, for example, $200 from X, and B is gonna take, for example, $100 from X, okay? Clear? So at the same time, assume A is gonna access the value of X, and B is gonna access the value of X. So A is gonna say the value of X is equal to 1,000, and B is gonna say the value of X is equal 1,000. Now, A is gonna deduct $100 from X. So the value of X is gonna be based on the A, local variable is gonna be equal 800, and the value of B based on the the value of X based on the user B is going to equal to what here? It's gonna equal to, let's say, 900, because I'm gonna deduct $100 or dollar. Okay? Now both of them are gonna store the data back to the disk, or the value is gonna be returned back here. So it looks like we're gonna end up, we have what? I'm gonna lose the data. And depending on which one writes the value last, the balance of the value of X may contain either 800 or 900. It depends who the one is gonna be store the value of X. So assume if A do this one first, so it's gonna store 800, then B is override, the value is gonna be 900. Or the opposite is gonna be, for example, B first, then override by A is gonna be 800. Both values are not correct, because the correct value of X is supposed to be what here? And it's gonna be 1,000 minus 200 minus 100, so the correct value must be 700. Because we don't have, we didn't handle well the concurrent access to the data, we have concurrent access anomalies. How can you solve that? We're gonna have, like, using database management system, we're gonna figure out a way how can we use the lock mechanism in order to make sure that this kind of situation never happen. Okay? Clear, awfully. Security problems, with another problem here. So it's hard to provide what's called the user access to the sum, but not all the data in the operating system. In the operating system, if you have a file X, and they say the only thing the permission that you have file read, right? I would say read and write and execute, right? Of course, this is for the owner, for the group, and for anyone else. But this is the way that how can we control the permission in the Linux system. The file X, for example, or say the table X is calculated students, let's go with the students. The student itself, there contains, for example, ID, name, GPA, and social security number. For example, something like this. I don't want to have every single user or anyone has access to the entire data stored in the student. So is there a way to have, like, specify or provide user access to the sum attributes stored in the student relation? Using the file system, I cannot do this one. Either allow you to read the entire file, or write the entire file, or execute the entire file. Nothing else. But for using the database management systems, allow us to give you an idea of the way that you can specify that. You can say the social security number is not available to every single user. Not everyone have access to this one. So you can limit the access based on the attribute level, or the fine-grained access control, which in this case, we don't have this luxury using the file system. So to generalize that, the database system offers a solution to all the buffer problems that we cover here. So next, I'm going to go over and discuss the concepts and the way the algorithm that enable the database management system in order to solve these problems that associate with the file processing systems. Okay? So in other words, we wanted to have the database management system to take all these issues, complexities. In other words, we want to offload all that sort of complex logic, how to manage the data in database. We want the database management system to manage that for us. Okay? Just it's worth mentioning here, we still have few people that are still confused maybe between the database with the database management system. When they hear database, they say it's the data itself, Or no, it's the data plus a set of software. You mean the database or the database system or the database management system. So again, the database management system, okay, or the database system is what? Is a collection of interrelated data, okay, and a set of programs or softwares that allow users in order to act, manipulate, modify the data in an efficient and convenient way. Okay? So the major purpose of the database system or the database management systems is provide the user, this is the most important thing, okay, with an abstract view of data. What do you mean exactly with the abstract view of the data? The system hides certain details of how the data are stored and maintained in the lower level to the user on the higher level. And I gave you an example similar to this one when we talk about the driver that will drive the car. The only thing that you need to know is what? How to control or operate the control of the car. Yeah, you need to know exactly how the motor is going to be executed, running, operate, and etc. We do have different types or many types of database management system. Postgres, MySQL, Oracle, Mongo database. We do have like SQL Server, and etc. There's many of them. Okay, we're gonna talk about the general purpose database management system, which is the one is gonna design in order to define, create, querying, updating, and administrating of the database, which is mainly gonna be relational database management system. So we do have different types of database management system in general here. So we can categorize the different types of database management system based on what? What kind of workload or application they can support. So the simple one is online transaction processing with OLTP. What does that mean in this case here? This is used in order to add in new data from outside world, which is the most of the application with this first query of the database or workload that we use is under this categories. For example, you log into your account and you want to modify username, your password, or you add some piece of information. So in this case, you're gonna have read update, okay, a small amount of data each time, and use this. And we use this query multiple times, okay? So again, it's fast operations, only include, read, write, or read, update operations for the small amount of data. For example, you log into the Amazon, or you try to buy something online, you log into your account, then after that you select specific items, then you pay for this account. So you have a limited number of operations you're going to perform, and you're going to touch small amount of data. The second part, or second workload, is online analytical processing. This is going to be mainly something more complex read only. Mainly the operation is going to be read only. And you're going to perform, read a lot of data, then end up you're going to, derive some new knowledge or extract, new knowledge from this data. For example, we talk about the example related to the Amazon. We have a multiple user and buy stuff from the Amazon. That's what can be considered online transaction processing. Then later, maybe the Amazon website is gonna say, okay, we want to see what's the most item, or find the most item bought in the last month. So in this case, we need to access a huge amount of data. Mainly, we're gonna read. Most operations gonna perform read queries, collect information, extract some new knowledge, and you can give me some statistical information. That's why they call this analytical processing. Not every single database can allow me to perform this operation. There is another new categories with a new definition. Is called hybrid transaction analytical processing, with combine both two in one. In the same instance, in the same database, you can perform two different transactions. You can run your transaction processing workload, and also you can use or run the analytical workload in the same database instance. So mainly in this class, we're going to cover the first one here, online transaction processing. But there is some data mining class. If you take a data mining class, especially mainly, you're going to perform that some analytical processing. You try to extract new knowledge. Mainly, you're going to perform a large amount of data. Then after that, you just come up or derive in your, let's say, finding in this case. Questions? Just want to make sure that we are on the same page. You're still awake. I mean, not exact, kind of. I know the weather outside is nice, so if you want to say why you're stuck with this guy, we're supposed to go outside, but it's windy a little bit today. Yeah? So anyway, so let's take a look at the early database management system in general. By the way, database system is not new, it's old. It's 1970 or maybe before that, okay? At that time, the early days of the database applications used to be difficult to build and maintain. And the reason behind that, because there is a tight coupling between the logical and the physical layers. What does that mean exactly here? Let's first talk about what do you mean by the logical and the physical layers. And after that, we're going to elaborate more on this part. The logical layers are going to talk about what? A Jewish entity or what kind of information can be stored. That's the meaning here. Okay, what's in the database itself? What the IDs, his name, and etc. And the physical layers, okay, how the database management system is going to actually store the data in the lower level until the disk. In the early days of database management system, or the application gets used, you need to have like a tight coupling between the logic and the physical layers. So let's go over what the Ted Cult did. And this guy was the guy that changed the whole database management system. Ted Cult notes that in 1970, I guess, if I'm correct, that people used to work in the database management system spend a lot of time just writing the database application over and over. Why? Because as I mentioned, there's a tight coupling between the logical and the physical layers. So in order to write your code, you need to figure out, to find out what's in your database and how we are going to store it in the lower level, into the disk. Okay? Either gonna store, remember, in the disk is gonna be sequence of bytes. So you need to decide which sequence bytes gonna be stored in specific block next to each other, which data structure use in order to store the data in the lower level. So in other words, at that time, you need to tell the database management system the following. For example, I do have this piece of information. ID, name, for example, GPA, etc. Okay? Then, I want to store this information using, for example, different data structures. It might be hash table, it might be tree structure. Okay? Using hashing, you know hash, yeah? So hash, that means you're going hash based on the ID, for example, and this one gonna be hashing into the number of pockets from 0 up to, say, p minus 1. It depends on the hash function that you're gonna perform. It looks like mapping the ID into a set of pockets. It depends on the value of ID. Okay? That's one way to perform the data. Then after that, you're gonna do what? Now, once you tell the database how the data can be stored, now you're starting building your application program in order to access data. Now, after you have this data, I know I'm telling the database store this one using the hash function. Then after that, I'm gonna build my application. So this is what it's called, the physical layers. Now, this is the physical layer. And my logical layer, how the data looks like. Then now, when I'm writing my application, I know that in order to use or access the data, ID and name and GPA, I need to use a set of, let's say, functions, which allow me in order to use the hash function or hash table in order to figure out where the data can be stored in the disk. What if you decide, by the way, the hash table, we're going to see this one later, is help us in order to perform what is called the point query. If you're looking for example, select star, let's write this one again, select star from whatever the table here, student, where the ID is equal specific value. That's what is called the point query. I'm looking for a specific point. So the ID is equal specific value. I can't do this one using the hash value. function or hash table. I'm going to hash the ID, and the ID, basically the value given here, is going to tell me exactly where the data is going to be stored. So it's going to help me to fetch the block that contains the information at the lower level. Okay? What if you said, no, my query right now is not point query. My query is going to be looking for the GPA between two different values. So it looks like I'm going to perform what's called a range query. So in this case, I need to do what? Select star from student, where, say, the GPA between 0, for example, 1.2, something like this. So in this case, if I'm building my database in the hash table, now things going to be changed. So what I'm going to do here, I'm going to delete everything from here, take the data back, create or tell the system, now I want from you to use a tree structure. Tree structure is the best way in order to build the index, which allow me in order to perform the range query, with the query that looking for the value that between two possible value, lower level, lower bound and upper bound. So you have to build everything from, again, you say, this is my data, now I want from you to store the data as a tree structure. So you start with specific value of the ID, and we're gonna build a tree, okay? Now I need to rewrite my code in order to do what? And use different, to say, functions which allow me in order to access the tree, in order to figure out how can you perform that query. So you see that at the time it's going to be complicated. Every time you have it, you need to understand exactly, you know exactly in advance what kind of query you need to execute. Then after that, you need to find a way or tell the database management system, those are this is my data, and this is how I want from you to store the data on the disk. Then after that, you're going to write your application. If you want to change different query, you have to do this one again and again and again over, which does make sense. Clear the problem. So what he did, what he has done, changed the whole future of the database management system, or database system in general. He proposed in 1970 the following model is called the relational model, which is still used until today. So he proposed what is called the relational model, and this relational model contains, how to say, 3 points. In order to, let's say, avoid this maintenance or avoid writing the application over and over. So what he said, the first one, or the first point in this model, is gonna find or define in high level, by the way, okay, that we are going to store the database in a simple data structure as a relation, or in other words, as a table. 1 second. Anyway, so first is gonna, in high level, is just to tell I'm going to store the database that I have in the data structure as a relation or tables. So you are going to organize the data. The data can be stored as a table. So data can be ID, name, GPA. This is a high level. Okay. Then after that, he said we are going to access the data through high level language. The way that you access the data is going to be an high level language. So you are going to tell the database management system, I want this piece of information. Then how could you get this data? It's your problem. Try to do your best. Okay, it's not my problem. Okay, I'm not gonna tell you the exact steps how you can get your data, because the database, I'm gonna leave the freedom to the database to decide what's the best way in order to organize, store the data in the lower level. Regardless of the way the data can be stored in the lower level, database know exactly how can you achieve the data. So in the high level, just it's gonna say, okay, give me select a star from the data where the student equals specific value. Then try to figure out the best way in order to perform that or extract the data. Okay, then how the data be stored? It's not my business. It's gonna be left to the implementation. It's not the part of the relational model. Okay. So we end up, we have what's called the clear separation between the physical, the way that you have stored the lower level, and the logical, with the layers, with the data, what's in the database, and how the database was actually going to store these data. When you talk about the relational data model here, we do have many data models, okay? It's not only the relational data model. We have a different ways of the data model. How can we organize the data? Okay? So again, the relational data model is not the only data model but the most widely used data model, which is the one that we're going to adopt in this class or work in this class. So in order to define the relational data model, or data model, in general, is the collection of concepts for describing the data in the database. It looks like the way that, how could you describe your database? In order to describe your data, my database, one simple way I can use the relational model was I'm going to describe the data as a set of, let's say, tables or relations. Inside each relation or tables, I'm going to specify the data as what? As a columns of attributes, and the record is going to be like a set of, let's say, record of the value for every that associated with every single column. So again, it's describing how the data is structured or organized in the system. So we have many ways in order to do this one. This is the data model. So here, when you talk about data model, we're going to define, for example, you have a data, what the relationship among the data. For example, you have one data and another data, and whether there is a connection between them or not. For example, one data is going to be related to information, has information about the student, and another data, let's say, contains information about the faculties or the instructor. And you need to figure out what the relationship, as you mentioned, instead of hate, maybe there's another relationship, for example, might be advice, or take course instructed by, or maybe, let's say, yeah, advice, I think, one interesting relation here. I'm going to define the schema. What do you mean the schema? Of course, within this data model, you are going to specify what the data semantic and the data constraints. With a set of rules that specify the data must have. For example, you can specify using the data model. You can tell me, for example, the student ID must be not equal null value. Must be unique, for example. There is no two students going to have the same ID, something like this. Or the value of the GPA must be between in this range. Lower bound and upper bound, etc. I'm going to cover this one more details later, but just right now keep in mind that the data model in general is like a way of describe how the data is structured or organized. We do have one terminology is called schema, which is very important here. A schema is the description of the particular collection of the data. Since you have a set of data, we have a relationships, data and the relationships among the data, and you wanted to give me the structure for every single data. In other words, you do have like a table contains information about the student. So the schema is going to be give me the description of the data that's stored in the student relation. Okay, so for the relational data model, since the data is going to be stored as, you say, a set of columns, and each column is going to have a specific value. For example, I can say ID name, GPA. So the structure of the schema, you have to tell me, for example, we do have an ID, and what's the data type of ID? For example, it looks like you build the class or struct, if you are familiar with the C language. You can say, for example, you do have an ID, and the data type of this ID is like string. Of course, it's not string, you're going to use different data types. I'm going to cover this one later, more details when we talk about the SQL. But right now, just keep in your mind that looks like we do have a set of variables, and each variable is going to have a specific data type associated with this variable. Okay, this is the schema of the structure. And it's going to be different between, for every single data model that we have, it's going to have different ways in order to describe the description of the data. Those are the set of, the rest of data model. We are not going to cover them in this class. With the relational model, the one that we're going to cover here in this class. The most database is going to cover here. If we have time, maybe we're going to talk about maybe the key value of NoSQL data model here. Different way, that we're going to use here. There's some way it's going to use different data model graph. You can use a document. You can use array matrix. Some older, obsolete, models. We used to have this one from decades ago. Does not exist anymore. The network model and the hierarchical model. The most widely used one, the relational model, which is the one that we're going to cover this course. In this class, we are going to use the university database. And the university database, which in order to illustrate all the concepts that we cover. Okay? So this university database contains information about the following: about the student, the instructor, the classes, the department, and the course taken by every single student. I'm going to keep tracking to all the information associated with the courses, for example, the grades for each course taken by the student and the grades that they end up or got for every single class. For every single class, who teach this class during that section, that specific semester, and etc. So all information can be in the university database. Okay. So a relational data model or relational model, which, as you mentioned here, you're going to use what? It's going to define or store the data as a collection of tables or relations. Okay. So if you have a data and the relationship between every single among these data, we're going to use or implement them or represent them using, let's say, tables. For example, assume that we have a student and we have, let's say, instructor. This is that data and this is another data, okay? And we have like a relation between them, say, advice. Okay? This is the relationship between two entities, the data here. So in order to use the relational model, we're going to represent the student as a table similar to something like this. Okay, then we have the student ID, name, department, and the GPA. This is information. So each column is going to have a set of attributes or has specific attributes, which tell me specific data type is stored inside this relation or this table or this data. For the instructor, it's going to has another table, and also for the relation advisor or the advice, you're going to have like another table which contains, for example, the student ID and the instructor ID. This information can be stored here. So each of them is going to be represented as a table. I'm going to cover this one in more details next lecture when we talk about the relational data model. Right now, just to give you an idea, this is the way how can we describe or organize the data. Okay? So again, in this case, if you take a look, each table is going to have a multiple columns of the attributes, as you mentioned here, and each column has a unique name. Must have a unique name. We didn't have one ID here, then we have another ID at the same column. No, must be unique name. And also each tuple, or we call this one a tuple or row that contains information at specifically, say in this case is instructor as a specific instructor, which is going to hold one value per attribute. They have a value for the ID, value for the name, value for the department name, and value of the salary. Okay, and this is, for example, the department tables. It contains information about the department name, building, where the building that's about to located, and the budget. Maybe someone will say, how can we get these attributes? This is, of course, after we analyze the database management system or university database, and we end up, we have the set of attributes that be stored here. You are going to perform the same thing. You start with the class project, you start with the ER model, collect information, you're going to start with a compare to come up with the ER model. Then after that, you end up with have like a relational model, something similar to this one. Okay? Okay, so let me check here. Yeah. Now we're going to take a look to the fundamental concept of the database management system. So I'm going to talk about the data abstraction. Remember we said that in the database management system, in order to manage the key, to manage the complexity, we're going to end up, we have some level of abstraction. We try to have some details on the lower level to the user, on the higher level. So I'm going to take a look first to the three-level architecture. Then after that, talk about the physical data independence. It's going to be more clear later when we talk about them, okay? So, in order for the system going to be usable, it's easy to use. So definitely we're going to, it must retrieve the data efficiently. That's what I'm looking for. Remember, the database management system goal here, in order to have what? We need to find out the way in order to retrieve, manipulate the data in a more efficient way, okay, and convenient way at the same time. So since you need to achieve the data efficiently and make the system usable, we are going to use a complex, to say, database system, or complex data structure, in order to find a way, in order to represent the data in a way that allow you in order to have a convenient, a fast way, or efficient way, in order to access the data. For example, I'm going to use a tree structure in order to facilitate, in order to help me in order to figure out where the record that I'm looking for, on the structure that I'm looking for. It's better just to store the information randomly, because otherwise you're going to have, it force you in order to store, or to say, in order to scan the entire file, yeah? In order to figure out what you are looking for. Okay, so as again, we can build an index or tree structure in the way that help me in order to find out my data more efficient way. But the problem with these complex data structures is gonna have like what? For the user, we need to make sure that the user, we need to hide this complexity for the user. For the user at the higher level, just say select to start from the data and all the complexity is gonna be hidden on the user. So the developer, in order to make it that, to simplify the user interaction with the system, they are going to do what? They hide the complexity from the user. Through what? Through several levels of abstraction. So now we have a 3 different levels of abstraction. I believe after you explain all of them, you gotta now figure out or find out a way. You gotta be 100% understand what do you mean by the level of abstraction or hide the, let's say, some complexity or some information. So we'll start with the physical level, the logical level, and the view level. What's the physical level here? The physical level with the lowest level here, I'm talking about the storage here, is in the physical level, is going to describe how the data is going to be stored, where it's located, how many bytes, what type of index is going to be stored in the data. As I said, so in this case, more details, we have, for example, a relation or table that contains information about the student ID, name, GPA. So we have one named Alice, GPA is 2.00, two Bob, for example, 1.6, and etc. For every single record, we need to find a way to convert this one as a sequence of bytes. And here on this level, on the physical level, we need to decide how can we organize them, how can we store them into the lower level. Whether you're gonna store each record next to each other, or maybe you're gonna say one record is gonna be stored in one block and another record is gonna be stored in another block, and etc. Whether you need to have, for example, we have a fixed length, let's say record, or we have, let's say, variable length. Those details, I'm not gonna cover them in this class. We cover these details in the CS 525, but just you need to make sure that at this level, we need to figure out a way, or need to understand, or need to describe how the data actually going to be stored in the lower level as a sequence of bytes. Okay, what kind of index that we have, whether we're going to use the tree structure or the hash table or the, how to say, heap file organization in order to store the data in the lower level. Okay, that's the physical level. The second level here, we call this one the logical level. So the logical level, we call sometimes conceptual level here. It describes, okay, what tables are there. Just tell me the set of attributes they have. So I don't, here in this level, I'm going to say, I'm not interested in how the data be stored in the disk. I'm just interested in that we have the student is going to have the ID, and the ID is going to be, for example, let's say string or varchar, and the IIT because it must start with a letter. Then after that, we have a number of digits. For example, you can say string. The name, for example, is going to be string. This is the data type. Then after that, you want to say the GPA, for example, maybe it's going to be double. Okay, later we're going to use different data types. Just go over these type of data, the following data types to simplify the process. So here, just to tell me what the data is going to be stored in the database. And also what the relationship between the student and, let's say, the advisor, or let's say student and instructor. All of them going to be stored there. So what tables are there? What attributes do they have? And what constraints should the database enforce? So in this level, in the logical level, I don't care how the data I don't care how the data can be stored in the physical level. I don't care. The only thing I need to know here, what tables they have, what the attributes they have, and also what the constraint that should be database have or enforce. When saying for constraint, that means for the set of attributes you can define, for example, the GPA must be between specific values. The GPA, for example, supposed not have null value. The ID must be unique, etc. Those are the set of constraints. We're gonna cover them later in more details. Make sense, guys? You follow me. I didn't hear your voice. I didn't hear anything from your side. Don't hide, don't use, level of abstraction between you and me, okay? Don't hide any details. Okay. So the third level of abstraction, we call this one the view level, which is going to be something in the high level. Sometimes I don't want from the user to see all the data stored here. So maybe end up we have a different types of say of a views. Might be have different views. For example, assume the data has the ID, name, and GBA, for example, the social security number, etc. For the user one, I'm gonna have a view one. View one is gonna have the ID, let's say, and the social security number. View two, for example, it have like the ID, name, and the GBA, something like this. So in this case, you are going to decide what information can be exposed to the users, what they are allowed to see, and just to make sure that we're on the same page. Not every single user can get access to the entire data here in the logical level. So maybe we're gonna hide some, let's say, details on the higher level, or maybe have a different views. For example, when you look into the blackboard here, when you get access to the CS525 course in the blackboard, you see that you have like this is a limited view that we have. The only thing that you can see your grades in this class, right? You cannot see the other student grades. That's the view that we have. I do have a different views in the class. So what I can see your grades and the rest of the class or student grades in this class because they have a different view of the data here. So sometimes use the view as a way in order to secure or to enforce the security of the data. We don't need, most of the time, we are not allowed to have the same user going to have the same access right or the same set of data they can see or they can view. So just to summarize them here, so the physical level is going to take a look how the data can be actually stored as a sequence byte in the lower level. Okay? And where it's going to be stored, and which data structure used in order to store the data. In the logical level here, just we're going to take a look at what tables are there, and what attributes do they have, and what the constraints should database, let's say, enforcing. This is going to be the logical level. So in the logical level, I'm going to hide the way how the data can be stored in the lower level. Here we have another view here. Since we assume that not every single user can have access to try the data, each of them they have different access rights, there will be different view of the data. So I can take the logical, the conceptual level, and divide this one into different views. For example, for the students, users, they can access the view one, which is going to have only access to your student ID and the GPA of the specific student. View two, for example, for the instructors, users, which they have different access rights, which in this case they can view more details, more information about the different users here. So maybe have different attributes, and etc. Okay? Questions? You're still alive. You're still here, I mean. Thank you. Thank you, Calvin. So, now we're going to define, let's say, okay, good. So now we're going to define some terminology. I'm going to talk about the schema, database schema, and the instance of the data. Those are very important terminology because we are going to use them during this class. We're going to say that, for example, this is the schema of the data. This is the instance of the data. So I want from you to be familiar with these details here. Generally speaking, the database is changed over the time. As information can be inserted, deleted, so it's going to be dynamic, okay? So I can define the database schema as following. Is what? Is the description of what? A particular collection of the data. The structure, how the data looks like. So here it's going to capture and describe the structure of the data stored in each relation. So in this case, if we have this database, or let's say tables or database contains 5 tables, for each table you need to define the schema, the structure, describe the structure of each table. How can you describe that? How can you capture the structure? I can do this one by specify that the attributes, list of attributes stored in each table associate with the data type for each attribute. For example, student, I'm gonna have the student ID and the data type, for example, is string. Then after that, the name, and which the attribute and the data type is gonna be string, and etc. Okay, the schema is time independent. What does that mean here? It's not changed frequently, it's changed infrequently. We rarely change the schema. Now in the database, in rare situation, we are going to change the schema. Once it builds, creates the tables, the database that I have, I'm talking about the structure. I'm gonna capture the ID, the student name, the GPA, and the social security number, for example, and the department. This for the student. For the structure, I'm gonna capture the following information. We don't change this one frequently. It's rarely we're gonna change this one. So that's why we call this one as time independent. So if we take a look at copy of the schema now, and tomorrow, and after tomorrow, you're gonna see that the student, for example, let's write the student, still have the student ID string. This is the way how can we write the schema. I'm gonna cover this one later, more details, just keep in your mind, that's what you're doing. The name is gonna be string, and assume that the GPA is gonna be double. So this is the schema for the student. If you came tomorrow or come tomorrow and try to check the schema, it's gonna be the same. It's not gonna be changed at all. The instance is what? It's the actual content of the database at the particular moment or point in time. It's gonna capture the current state of the data. So what is the instance of this relation for the student? The instance of this student gonna give me what in this case? Let me give you an example. Go back here. This is the instance of the structure table. This is the instance of the department tables. What's gonna do what? This is gonna give me what's the actual content of the database at this time. So now we're gonna see this is the content of each of the current state, with the actual value gonna be stored here. This one might be changed with the time. It's time independent. So in this case, when you change it, it's time dependent. Sorry. So that means at time 0, maybe the value of the structure gonna be looks like this one. At time t equal 1, maybe after 1 day or few days, so the data gonna be modified, changed with the time. Maybe we're gonna insert a new instructor, maybe you're gonna modify a few instructors, so there is no guarantee that it's gonna have the same instance. That's why we call this one time dependent. Change frequently, because we keeping saying that the database systems, the databases, it change over time as information is inserted and deleted. Of course, if you don't modify anything, so it's gonna be the same. Okay, but this is the formal definition here. Clear? So the schema, let's write the schema. What the schema of the department here? It's gonna be have the department. I'm lazy guy, I'm not gonna write the entire name. So it's gonna be here the department name. And the data type is gonna be string. And let's say the building. It's gonna be string. And let's say the budget. Maybe it's gonna be double. Okay, so this is the schema of the department. And you can have the schema of the instructor with ID. We have a name, the type, we have the department name, we have a salary. Okay, and what's the schema of the database or database schema? It's gonna be the schema of the instructor plus the schema of the department, or the schema of the tables. Okay, so we know what do you mean by the schema and the instance. In order to make sure that we understand, let's say, the exact definition here, I'm going to give you just an example using programming language and show you what do you mean exactly the schema and the instance. Just give us an idea, or hopefully it's going to help us to completely understand what do you mean by the schema and the instance here. So assume that in the programming language, when you declare variable, you're gonna say, for example, integer I, right? You declare variable I, and the data type of the I is gonna be integer. Okay, that's the database schema, which is corresponding where they say the way that, or corresponding similar to the way that, or correspond to the variable declaration in the programming language. So the schema here for this game is gonna say the I is gonna be integer. All right, that's what we have here. So here each variable is gonna have particular value at a given instant. For example, during this code, maybe you're gonna say I equal 5, and later you're gonna say I equal I multiply X or whatever. So the value of I here is going to be the instance. What's the current value of I here? Is equal 5. We're going to capture the current state of the data. Then after that later, what's the current value of I here? It's going to be I multiply X. And it's going to be, maybe it's going to have a different value. So that's the instance of the data. Okay, which is the value of the variable in the program at the point or at the moment, or the particular moment, corresponds to the instance of the database schema. Hopefully this analogy is going to help us to understand what to be the database schema and the instance in general. Since we have 3 different levels of abstractions, each level is going to have its own way in order how it has its own schema. Because the schema is going to help me in order to describe the structure of the data at each level. For example, in the physical schema here. In the physical schema, we're going to do what? We do have like a schema that describe the database design at this level. So here it's going to define how the data will be stored in the secondary storage if you store the data in the desk, for example. Assume that a student table which contains multiple records. We do have, for every single record, we can store that can be described as what? A block of consecutive bytes. For example, you have a student, number of students, and the student is going to have student ID, name, and GPA. For example, 1, Alice 2.00, Alice. For this record, it's going to be stored as a sequence of bytes. You need to specify here the schema and going to tell me, for example, for the ID, we are going to specify, for example, 5 bytes. For the name, we are going to specify, for example, 20 bytes to store this data. For the GBA, we are going to specify, for example, 15 bytes or 5 bytes to store this information. So that's one way in order to perform that, okay? So we need to have like schema or something or some description in order to help me in order to retrieve the data that's stored in this level. So we need to have like extra piece of information, metadata, which help me in order to decide or figure out this one. In the logical schema here, the one that I just showed to you here, which describes the database design at the logical level. I'm not going to be trusting in the way how the data can be stored in the lower level. But the only thing I'm going to have here, I'm just describe the data at the logical level. So what does that mean exactly here? I have a table and the name of the table, then inside of the table, I need to specify the structure or the set of attributes stored in this table in addition to their data types. So I can say the ID and it can be string. And I don't care how many bytes that I need in order to store the string because I'm not going to store them in the physical level. I'm just in the logical level. Then after that, you need to specify the constraints associated with every table if they exist, if any exist. Okay? And the view, as I mentioned, maybe it's going to have, we have a sub-schemas here. Which is going to do what here? Database maybe also have a several schemas at the view levels because we have, as we mentioned before, not every single user is going to have the same access right or the same piece of information can see. So we need to have for every single bunch of users, we do have, let's say, different views. Okay? And in addition, we can use the views in the way in order to provide us a security mechanism. In order to prevent, say, user from access certain part of the database. For example, you have the user, or let's say you are the secretary, a staff member at the computer science department. Maybe this staff member acts only the list of the instructor of every single instructor in the computer science department, but they cannot have access to the salary, for example, or their social security number. So I'm going to create a view that contains only the instructor ID, name, and address, and I'm going to exclude, for example, the social security number or the salary from this view that this staff members gain access to. We call that sometimes sub-schemas, okay? Because it's going to be similar to the logical, but in this case, you have like, fine, great, we have a different views. So let's take a look here. Just you have examples for the university database, how it's going to be stored in different levels. So we'll start with the conceptual, the logical schema, and we're going to use based on entity relationships here. This is, the design that I have. This is the one that you're going to see later. How can you build this one when you create our ER model for your data? So we have a student, we have a course, and just we have a sample data. We assume that here the student is going to have the relationship with the course with enrolled. That means the student is going to be enrolled in this course. And those are the set of attributes associated with the student. Those are the set of attributes that associate with the course. And this is one set of attributes one attribute that associate with the relationship. So in this case, for every single student, it's going to be enrolled in a specific course. And this is the grade that will be associated, can be stored in the role. This is one way to organize this data. Okay? So the relation schema is going to say what? How many relations we have? We have entity, we have or table. We have a student, we have a course. So tell me, the student have the student ID. And this is the student ID. Okay? And let's see, write this one, different color. Yep. This is the student ID, with this one here. Then after that, the second attribute is the name, which is going to be the data type. Remember, by the way, pay attention, the data type is going to be changed later when we talk about the database management system. Later we'll talk about the query language, different query language. I'm going to show you that we have like a specific, say, data types that we can use in the database system in general. So integer, string, etc. Maybe you're going to see that we have a varchar and a char, etc. But I'm going to use here integer, string because it's easy to understand right now. We are familiar with these data types, okay? The major, for example, the third one, string, address is going to be string, and date of birth, for example, is going to be data type is called date, which contains information, okay? And the course is going to be for the same operation here, the same structure. And in all, you're going to have, in this case, someone is going to say, how can you perform this one? Later, I'm going to show you when you convert to the ER model to the corresponding schema. Actually, this is phase one, something similar to this one. And this is going to be phase two. So you're going to show you the steps, how to convert from the ER to the corresponding relational schema. Okay? So that's what I expect from you for the phase one, and this is what I expect from you from the phase two, something like this. It's easy if you understand how to do that. We are going to cover this one later, starting next lecture. Anyway, so for enrolled, you see that you need to have the primary key of the student with the course ID, then the grade. So it looks like this student that enrolled in this course, and this is the grade that the student got in this course. Okay, so what's the physical schema here? So this is how the conceptual, the logical schema looks like. For the physical schema here, we're going to have the relation going to be stored whatever in unordered files, because a way that we have a different ways in order to store the data. Either we're going to use this one and say the sequential files, they're going to be stored next to each other, or maybe they're going to be random. We'll use heap files if you are familiar with this one. If you already studied the operating system, so you know exactly what do I mean here. If you store the data randomly, you didn't specify it's not next to each other, or maybe it's going to be in the sequential blocks, or based on, say, an index, so you have in the sorted order, and etc. Okay, whether you're going to have index information about each index that associated with every table if exists. Then we have like the schema views here. Maybe you're going to specify course info, which contains information about the each course and the number of enrollment in this course. Either specify new relations, or maybe this one gonna be somehow we're gonna, for example, for the student, maybe I need to have specified view that contains student ID, major, name, and address without date of birth, for example. So there's gonna be another scheme. So here maybe you have a different views. Just to give you an example for the view here. Okay. The other thing I talk about, we talk about the 3 level of abstraction. We said we do have another physical thing we need to cover, which is called the physical data independence. What does that mean in this case here? The concept that we need to do here, we need to follow, we need to achieve here, application don't need to worry about how the data can be structured and stored. When you're building your application at the higher levels, Do you want to need to care or understand or find out how the data is going to be stored in the lower level? No. This is the interesting thing in the database management system. It's not the file system. It's a database management system going to take care of the lower level here. So since we have a high level of different level of abstraction, we do have the physical level or the physical abstraction, which is going to hide the way that details about how the data can be stored in the disk. Regarding the way that stored the data, definitely is not going to affect the applications in the higher level. So the physical data independence here means that the ability to modify the physical schema without changing the logical scheme. For example, we say the logical schema still we have the student ID, this is student. We do have ID, we have a name, and we do have like the GPA. Okay, this is my logical scheme. Now in the lower level here, maybe I'm gonna store the data in the lower level. Instead using 32 bits, I'm gonna use 64 bits, for example. If assume the value of the ID is an integer. In my system that I store, instead uses 32 bits in order to store or represent an integer value or data type, I'm gonna be 64 bits. Does that affect the higher level? No. Does that affect the scheme? And you say the logical schema? No. That was called the physical data independence. For example, maybe you need to compress the data on the lower level. So still, this one is not going to affect the logical schema. So the logical schema is going to be intact without any change, regardless of the way that you're going to use in order to store the data. Whether we're going to store the data in the lower level using the, say, heap file organization, or maybe you're going to use the, say, tree structure organization or the hash table organization. No, it's fine. I don't care. I actually care, but in this case, it's hidden for me. So this one is not going to affect, regardless of the way that's stored in the lower level, it's not going to affect the schema in the logical schema, I mean here. So still we have a student, ID, this is the data type, name, this is the data type, the GPA is the data types. Okay, and sometimes, for example, move the table to another disk or machine, it's not going to affect the way that how it's going to be stored in the lower level here. Of course, if you move the data somewhere else, you need to figure out the way how to connect at the server at that side. That's a different story. But the logical schema is not going to change. Okay? Now the interesting part here. I'm going to go over different types of the database languages. Remember we said the relational data model design, like show me the way how to describe the data, and also gonna give me like different ways in order to, or declarative way, or way in order, abstract way in order to access the data here. So I'm gonna talk about the database language in general. We do have many language, different types. We summarize them into 4. Some textbooks they have a 5 and 5, I guess. So first I'm gonna talk about the data definition language. Then after that, I'm going to talk about the data manipulation language, data control language, and transaction control language. Okay? And don't worry, you can use SQL in order to perform all these jobs here. Okay? So what's the data definition language? Defined as what? The data definition language is defined as what? It's used to create a schema, tables, you know schema, yeah? It creates a schema, tables, index, constraints, and certain the databases. Now, for example, when you work with a database, you need to create a table that contains this information, right? How can you perform this one? I'm going to use the data definition language. So this one is going to be a specific language that contains a set of rules or commands which allow me in order to create a table, schema, index, constraint. And also you can modify the data if you want. You can alter the structure if you want. Okay? So I don't know who's calling me right now. I never answer phone call. Anyway, if this guy call me again, I'm gonna accept his or her phone call, and I'm gonna continue the continue the class. I'm gonna ignore him or her. Anyway, so this case doing what here? If you use a SQL was a structured query language. We cover this one later. which provide a rich data definition language with a set of commands that allow me in order to create, define tables, etc. So what do you mean? The data definition language is this language that allow you again to define database schema, define, let's say, tables, index, constraints, and etc. And also create a database. And you can modify that later. So in the SQL, I can say create table, department, and you can specify the data type the attribute name and the data type for every single, that associate with every single attribute. And here you don't, we're going to use a char, about char, and numeric. We're going to cover this one later, which is different data types you use in order to represent the data or attributes that are stored in the system. Okay? Sorry. That's, the data definition language. Data manipulation language, which the language is used in order to what? To act for access and manipulating the data in the database. Here, I'm not going to create a table. I'm not going to create a schema. No, I'm going to have like a command that will allow me in order to access and manipulate the data. So it looks like I'm going to mainly focus on the instance of the data. Okay? So for example, you can select the data, retrieve the data, you can perform insertion, you can delete, you can update. For example, you can add a new instructor, for example, if you deal with the instructor relation. You can delete a specific instructor, and you can, let's say, update specific instructor, specific attribute associated with this instructor. So mainly we're going to focus on the instance of the data. Okay? Here, there's some text box that you're going to do what? You're going to say the data manipulation language is the way that just to manipulate the data. And we do have a data, I would say, a query language with another language or another type of language which allow us in order just to retrieve or access the data. I prefer to put them under the data manipulation language, and I prefer to say the data manipulation language which allow me to use to access for accessing and manipulating the data. So I need to define, so here it looks like I'm working in the instance of the data. The content of the data is not the schema. I cannot touch the schema. Okay? So here I need to define the query with a statement that requesting the retrieval of the information. I think I need to, give me a second. So anyway, so I need to define the query. If you hear query, that means is a specific statement that allow you in order to retrieve information. So generally speaking, in the SQL query, that means you have to use a select. I'm going to say, give me the data. I'm just looking to access or retrieve the data. Okay? The portion data manipulation language that involves information retrieval is called the query language, which is going to be part of the data manipulation language. So the query language is going to be used a query with a specific statement in order to retrieve the data or access the data. So definitely the SQL query, you're going to say select. Select whatever. So in this case, we are going to retrieve the data. We do have another part of data manipulation language which allow me in order to manipulate the data. So instead, we're going to say select. I'm going to say, for example, insert. Or I'm going to say delete. Or I'm going to say update. So here in this case, you are going to modify. You are not going to retrieve the data. You are not going to access the data, but you are going to manipulate, modify the instance of the data. Okay? Later, we're going to cover that in more detail. But right now, the most important thing I want to distinguish between what do you mean by the retrieving or access the data and what do you mean by the, let's say, modifying the data itself. Okay? We do have two different classes of language. One of them is called pure, and the second one is commercial. The pure, the one that used in order to proving properties, which help us in order to perform for query optimization, etc. As example, you're going to see relational algebra, tuple relation calculus, and domain relational calculus. We're going to take just an example later, talk about the relational algebra. Another one type of the language here for the data manipulation language in general, the second one is called the commercial. With the one used in the commercial system, the most important one is the SQL or SQL, with the most commonly used commercial language. In the data manipulation language, we are going to define, there are two different types here actually. The first one, procedure, data manipulation language. The second one, the non-procedural or declarative data manipulation language. What do you mean the procedural data manipulation language? So in this case, when you write this query, or you command whatever database statement using procedural data manipulation language. So here in this case, you have to specify the user what data that you need, what you want to achieve, or manipulate to do whatever, and how to get this data. As example in the relational algebra. Assume that in order to get relation, let's say, information or whatever data from, let's say, a specific data table. Assume that we have a relation R. I'm going to say I need to perform the selection over this relation R. For example, filter out the tuple. I'm going to cover this one later, but selecting that means I need to perform filter out, go over every single tuple in the relation R, and only the one that satisfies the condition that's specified here can be part of the result. Then after that, I'm going to perform the projection. Projection, that means here you need to filter out, not all the columns going to be part of the result. I need just, for example, the ID and the name, for example. And you can say the ID is greater, or the GPA is greater than 1.00. This is the condition that we have. Anyway, for the why I wrote this one something like this, here I'm going to give you what I need in the result, and also I show you the exact steps. So you have to X the relation R, then after that you have to perform select to filter out the tuple that does satisfy this condition. Then after that you have just to retain the column that's specified here. I give you the exact steps. The other types of the data manipulation language is called, they say, declarative data manipulation language. Which is this one is going to require the user to specify what the data are needed, but I'm not going to tell you exactly how could you get the data. So in this case, actually it's better to say SQL. So SQL, because easy to write the query, I can say select, let's say ID and name from, let's say, relation R, and where, let's say, the GPA is greater than 1.00. Here's the declarative language. What I've done here, I said to the system this information that I need, and go ahead to find the best way to execute or find how could you come up with this result. Okay, so there's a different way to perform that. So the system going to specify how it access the data, whether it's going to use index or not, and the system have a different ways in order to access the data in order to achieve the result. Maybe here there's no big difference because I'm going to access one relation, but if you have two relations, the situation is going to be different here. It's going to be more clear. The structured query language offers the both data definition language, SQL, and the data manipulation language statement. So allow me in order to create, say, schema, tables, index, constraints, and also use to access, say, statements that allow me to accessing and manipulating the data in the database. Okay. The data control language, which the one is going to perform what here? It's going to include the commands or statements which allow us in order to grant or revoke access rights. Remember we said talk about the security, okay? And we said maybe in the file system, since we cannot do this one, the database management system allow me in order to specify who accesses what, and also I can tell or I can specify the access right or security, access right or privilege or whatever kind of security, who can access even a set of attributes, specific attributes within this relation. So the simple thing here, if you have a relation R that contains the ID and name and the GPA here, you can specify, for example, who can access the relation R, who can perform select in the relation R. That's what mean the grant. Who can perform insert, add a new tuple in this relation R. Who can perform delete over the relation R, and etc. You can specify this one, and also who can update, and you can specify who can update which attributes. You can specify some user can update the GPA, some of them can update the name, and etc. So you can specify what access right, what the right, the permission, and also you can revoke them. You can grant this one and you can revoke them. Okay. I'm going to cover all of them during this class, but right now just I want from you to be familiar with this kind of controls that we have here. The last language we need to cover today is called the transaction control language. When you talk about the transaction, generally speaking, the transaction is a collection of operations that performs a single logic function in the database application. Remember when we said we tried to transfer $100 from account A to account B, we said we need to perform this operation as one unit. For example, say take the balance of A minus 100, then after that the balance of B plus 100. Right? We've said this one must be executed as one unit, as atomic. We can define this one as a transaction with a set of operations going to be performed, and you want to from the system to make sure that those set of functions or operations must be executed as one unit. So we can say begin transaction, and at the end you're going to say either going to be commit or rollback. Here you can specify beginning of operation. So he said from here to here. You are not going to reflect that change to the disk until you see commit. That means anything modify. If you reach this point here, you have to make sure that the change that we have done here in the memory must be reflected in the disk. So at the end here, now the balance of A is going to be minus 100, and the balance of B is going to be added or has one extra 100. Okay? Sometimes you have the chance in order to change your mind or undo whatever you have done here. So it depends here. Sometimes you're going to perform some operation. You can say this block or this set of operation or this transaction and going to be executed as one statement, okay, as one unit. And at the end here, maybe perform multiple operations. Maybe you get to extract the value of x, then as y. Then after that, you perform x divided by y here. And you realize that the value of y equals 0. So divide by 0 is going to cause an error. So what you're going to perform here, I'm going to say this set of operation is going to be deleted, it's going to be ignored, and going to be undo. So in this case, I can say rollback. So that means start the commit transaction here. At the end, you're going to say rollback. When the system is so rollback, that means whatever I'm going to operation I perform from begin transaction until the rollback, it looks like I never execute that. I changed my mind. Later we're going to cover that in more details, but just keep in mind this is what it's called, the transaction control language. Yeah, my voice getting lower and lower and getting worse. Anyway, so the SQL query language, we define this one non-procedural declarative language. So in this case, just to tell the database what do you want as a result, but I'm not going to tell the database how exactly you're going to retrieve the data. Okay? Sometimes SQL query language is not enough. Okay? So when you build the web application, you need to collect information from the user. Yeah? We don't have SQL query command that allow me in order to build fancy, let's say, login form, or actually login form. When you log into the MyIT, you see there's a fancy login form. They're required to collect information from the user. Then after that, you send this one, create a SQL query somehow in the backend or background in order to execute at the server side. Then after that, you're going to return with a dynamic page. Sometimes, for example, we wanted to print out the result or display the result in a specific format. So the SQL is not enough. So maybe we need to have a way on the first us in order to embed the SQL into some higher level language. For example, I can use Java, Python, or PHP, ASP, whatever language we're going to use in order to allow you in order to inject the SQL command or statement within this one. Because I'm gonna using this higher level language in order, for example, create a fancy form or form in order to collect information with the user. Then after that, I'm gonna somehow use the embedded SQL in order to send or create dynamic SQL command or statement. Then after that, it's gonna be executed as a SQL server or the server side. So anyway, some language extension which allow us to embedded SQL, which can be, in this case, within, it's like PHP code inserted inside the HTML code. So inside you can, this, I think it's, remember, PHP, something like this. Yeah. So here I'm gonna insert PHP code. So for the SQL, somehow some programming language allow me to order to inject, let's say, execute this SQL, and here I'm gonna say select whatever the command. It's gonna be right the exact command how it looks like, and here end SQL, something like this. That's what is called the embedded SQL. We are going to cover that later in more details. Or we are going to use some program interface like JDBC, for example, if you work with the Java, in order to connect to the database server, which allow you in order to dynamically create a SQL query. Yeah, which is going to be covered in the chapter 4, 5, 6 in more details. Or Python, if you want to use Python, in this case you are going to use PsychoBG2, which I think is one of the more popular interface that allow me in order to use a Python connect to create a SQL query using the Python. Okay, so that's means in this case we're going to use what is called the application programs, with a program that you use to interact with the database in this fashion here. Okay, so I'm going to write a form using whatever programming language. It's going to be the user ID and the password. When I say connect, then in this case inside this one I'm going to take the ID and the password and we create a SQL query. For example, select star from, let's say, login, where the ID is equal the value I got here and the password is equal the password that you perform here. Something like this. Okay, so I believe I'm gonna stop here. Okay, I feel my situation gets worse. I know still we have 2 minutes, but I'm gonna make it up to you later. Okay, next class. So next class we're gonna talk about the database design here, and we're starting with talk about the relational data model next lecture. Don't forget, I'm gonna send you email tomorrow, which contains a link to the shared document, Google document, where you have a chance now starting, you say, form groups for the class project. And you have up to May 31st in order to finish, in order to select your group member. Thanks, guys, and see you on Thursday.